Right, I'm ready whenever you are, my friend.
We're living on a disk, floating through space, with a tiny sun.
Hello, and we should be live. Can everyone in my stream please let me know if they can hear me and if they can hear Sleeping Warrior? Say something, Sleeping Warrior. You there? Hello? He was literally just there. Whoa, what's going on? Can you hear me, dude? Anthony, you there? I can hear you clicking.
All right, my intro's finished there. Are you still with us?
Yeah, I'm here. Can you hear me?
I can indeed. Are we good to go?
We should be, yes.
Let's dispense with the formalities. We both know which we are. I am Sleeping Warrior, and my opponent for tonight is Fight the Flat Earth.
First of all, I want to say sorry to you for yesterday. I don't know what happened. Literally, the second I was about to start, my new computer just stopped working, gave me a blue screen. So I'm sorry for the muck-up yesterday, and I appreciate you taking the time to speak to me again today. So thank you for that.
No worries, it's cool, man. I appreciate the fact that you did it personally after the hangout last night as well, or was it this morning?
I feel bad. I don't like letting people down, so I wanted you to make sure that you knew I wasn't fucking you around.
Nah, apology accepted. It's all good. We all have moments of nightmare, and PCs are no exception.
Excellent.
Right, let's get on with the show. What shape is the Earth, sir?
The Earth is an oblate spheroid with a circumference of approximately 25,000 miles or 40,000 kilometers.
Right, any evidence to prove that that's true?
There is much evidence. The question is, what evidence will you accept? Will you accept images and videos? Will you accept third-party accounts? Because obviously I can refer to every image and video that's ever been taken from space to show that we live on a globe that says that it is what it is.
I will accept any evidence that does not satisfy the definition for pseudoscience. On screen for my audience, I've got a definition that's just literally, if you type in pseudoscience definition in Google, the top result just defines it as a collection of beliefs or practices mistakenly regarded as being based on scientific method. So if we can get it outside of that definition so that it becomes science, then I'll accept it, or at least consider it as credible. If it falls into that definition of pseudoscience, unfortunately, I'll dismiss it and I'll do it to your face.
Okay. I mean, I'll probably disagree with you on what you consider pseudoscience, because I'm pretty sure we will have a disagreement on what the scientific method is.
Sure, of course.
If we want to talk about experiments that show the Earth is the size that it is, there's a guy called George within our community who has been doing a lot of observations. He lives like in Alaska, and he's been doing a bunch of observations like over a year, and he lives like on loads of ice, and he's been over there he's doing it for longer than a year, but he's been taking observations constantly for a year in these long stretches that he has near him, and it shows that there's a curve that matches what we say. It included laser observations, he's included reference point observations, and it always matches out to what we say. I was trying to find his YouTube channel for you, but hopefully someone in my chat will get that for me. Then we could look at things like the Bedford level experiment when it was actually done correctly.
Did you say
curve like we say it is?
Did you say George is in George Netanuk?
That may be his surname's quite an old guy.
Yeah, he doesn't live in Alaska. Did you say Alaska?
Somewhere up north in America, Canada probably.
Alaska's not in America, though, right?
Well, Alaska's part of USA.
Are you sure?
Yeah,
It's
Alaska's
to the
part of the
east.
States.
It's to the west coast of Canada, isn't it?
Well, yeah, but it's still part of the United States of America.
As far as I know, he lives in Minnesota, North America. He's not
Right.
in
Okay.
Alaska. But
Yeah.
anyway, point aside. All right. So do we agree that there is a difference between theoretical physics and experiment-based science?
Yes.
What would you say the difference between the two is?
Well, theoretical physics is obviously much more based around mathematical derivations of theories, whereas experimental physics and actual physics will be things that you can physically do experiments on, like testing the acceleration of gravity and things like that. That's not theoretical. We know that we can measure the acceleration that we experience on the planet. So theoretical sciences would be things like talking about dark matter, dark energy, black holes, because we have to look at the maths that we understand to kind of understand that. But things like measuring gravity and things like that, I would say would be physical experiments.
Well, measuring something's not technically an experiment. It's part of the process, but it's not
Part of the process,
not right.
Yeah.
So my question is, what weight should we give evidentially to theoretical physics? Is it strong evidence? Is it 50-50? Or is it weak and should be dismissed?
Oh, no, it definitely shouldn't be dismissed, because theoretical physics is an extension of our understandings. I mean, when you look at science, obviously we don't have all of the answers. We have the best explanations that we're able to get from looking at our observations and doing the maths to figure out if things fall into place. And I know that a lot of theoretical physics has a lot of questions around it as to whether it's valid, whether the theories are correct. You go right down to the very base of like physics with looking at quantum loop gravity or string theory. We know that there's energy base there, but we don't really know exactly what it is. So we have to use a mathematical model to try and describe it as best as we can. And I don't think you should ever dismiss a mathematical model until it's been thoroughly disproven.
Well, why would you rely on a mathematical model given that it's mathematical by nature?
Because a model is a way of describing your reality. And the way that you see if a model is correct is by using the model to make predictions. And if the predictions work, then you say the model's correct. And that's what you would go with until a better model comes along that not only explains things as well, but explains them better. And so far, I don't think I could say conclusively there isn't anything that explains things better than the current understandings we have.
Would you say that a mathematical model is conceptual? It's not physical. It's not tangible. It's not practical. It's not scientific in that you're not able to do anything with it other than calculate mathematically.
At points, I will say that there is things about mathematical models that are they have to be conceptual. They have to be a derivation of the physics that we understand. But there is parts of the model that you can test, and when there's parts of the model that you can test that work, and the rest of the maths fits in with that, then I would say that it has all been figured out to work and be correct.
So if you're going to use something that's conceptual by nature, it lacks tangibility. It's not something that's like you can't manipulate it. You can't throw it. You can't touch it. You can't do anything with it because it's mathematical by nature. Why would you treat that as though it's real in the sense that you're going to base your perception of our cosmology on it when it's based on maths? It's not based on the real world.
Because maths is the world. Maths describes the universe. Maths is a universal language that everybody can use to understand the same things.
Maths isn't reality.
I would 100% disagree with that. That maths isn't reality, because everything can be described with maths. Absolutely,
yeah, describe.
Everything.
Yeah, so I agree. Everything can be described.
In that basis of the fact that everything can be described with maths, then maths is reality, because it's a description of reality in a language that everybody can have a basis of that is the same.
Okay, So on a video that I presented on my channel on the 6th of Feb, if you haven't seen it, it's called The Science of Deception, featuring gravity rammed down our throat. It was aimed at yourself, and in that video, you did respond to it. You made some really bold assertions, and I addressed them with reference to a particular citation from Scientific American.
Yes.
And you did do a response video, and one of the things that you said, you said numerous things in the video, but one specific thing that you said in the response video on your channel was that I shouldn't use this Scientific American document to prove anything. And
yeah,
I didn't use.
I stand by that because it's.
Yeah, hang on.
Sorry,
hang on. I didn't use it to prove anything other than what the current science is, which is why I want to now reassert this point, because I'm not using it to prove something. All I'm asking is, at this point, with regards to gravity, because I've heard you say a lot of stuff to do with gravity, how it's a repeatable, verifiable thing. But I want to know, what is your understanding of gravity per science as it stands today?
Okay, so the way that I describe gravity, so that people can understand it using all the physics that we understand, is that gravity is a warping of space-time that can change the locality of things that within Newtonian physics manifests as an accelerating force. Right.
So what you're saying is, how does it interact with Newtonian principles? You said that, does it add to it? Does it refine it? The
way that you have to look at it, Newton, in the video that you showed me, where Brian Cox described the whole thing of the apple falling on Newton's head. I mean, that didn't actually happen, but that's by the by. Newton saw gravity as an invisible force, right? He didn't really know what gravity was at all. What Newton did was come up with the universal law of gravitational attraction, which is the F equals gm1m2 over r squared, which can accurately predict the way that things fall and the way that things move in the universe that we observe. Now, again, he assumed, or he just thought it was an invisible force, whereas Einstein came along and said, well, no, it's not a force. It's a literal warping of space-time, which, like I said, changes the locality of things. But within Newtonian physics, it manifests as a force, and we can say that because there's an acceleration when things fall, and we know that acceleration requires a force. So there was a lot of things about gravity that Newton got very wrong. I mean, he lived a long, long time ago and didn't have a lot of the understandings that we have. But his observations were, and his mathematical law was based on physical measurements of things falling, and not just falling, but accelerating at 9.8 meters per second squared.
Okay, so just clarify. The question was, how does Newtonian and Einsteinian gravity interact? Did one add to the other, refine it, or did one replace the other so that one becomes obsolete and antiquated and the other one replaces it? What was the interaction?
It was an explanation, a furthering of the understanding. It didn't replace it. It didn't say that, no, that's not what it is, and that's completely wrong. But it took you could say that Newtonian gravity is the what, and Einsteinian gravity is the why. The two are intrinsically linked. They're not like separate things, completely separate entities. They describe the same thing happening, but Einstein gave us a lot of more explanations as to why these forces and these attractive accelerations happen.
Okay, I'll credit you with a correct recite for what you actually said. What you've said now compared to what you said in the video are the same. However, what you said now and what you said in the video are incorrect. What the current position by science is that, and I'm reading from that document that you ignored in the response video, relativity snapped the wand in two by showing that the curvature of space-time, and specifically not an invisible force, gives rise to gravitational attraction. But we have a problem. Because if we're going to go with the bending of space-time, bearing in mind that we've just spoke about concepts, mathematical concepts, and whether they're reality or not.
Yeah.
If I now type in space-time in Google and look up the definition for space-time, it's defined as, by Wikipedia, it says, in physics, space-time is any mathematical model that fuses the 3 dimensions of space and the 1 dimension of time into a single 4-dimensional continuum. But the problem is the definition of reification fallacy is treating something that is conceptual as reality. So on the one hand, we've got relativity that snaps the wand of Newtonian principles of gravity in two. In other words, it's antiquated science now. It's not a refining of, it replaced it completely. That's out the window. But it's replaced it with a mathematical construct. And the mathematical construct, by definition, with it being maths, is a reification, because it's literally conceptualizing something that's mathematical rather than proving it experimentally, which takes me back.
I'm going to have to disagree with you about
just
the fact
hang on,
that
just not bear with me.
Sorry,
I quite finished my point.
Carry on.
Which takes me back to my original point, to what value should we give something that's theoretical by nature? Because the maths, I didn't realize I wasn't presenting all that presentation then. The maths that's presented by Einstein is theoretical physics, because it's not capable of any experimental testing, because its construct is mathematical by nature. So my question is, if Einstein replaced Newton, but Einstein is purely mathematical, if it's got no application experimentally, what is the value of this theoretical physics that Einstein presents that's mathematical in proving gravity as anything? How are we going to prove it if it's purely mathematical?
See, again, I would have to disagree that we have discarded Newtonian gravity, because that's not the case. We use the Newtonian law of gravitational attraction and the equations around that to figure out how to send men to the moon. So those equations that Newton came up with to describe the attractive force are still as relevant now as they ever were. What Einstein did was try and describe why that force is happening. I mean, when you get into higher end physics, it's not even really a force. It's much more to do with energy and mass. But that's a conversation for another day.
So you started with the sentence, I disagree with it because it didn't really replace it. But on screen for my audience right now, I've got that Scientific American article that gives the current science, right? It's not proving something. It's just outlining what is the current science. So if you're going to disagree with me, which is cited by Scientific American for literally snapping the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction, I'm going to ask you if you've got any other evidence to support your disagreement, because at this point I'm asking you to prove that your disagreement's got substance or validity within science.
Yes, 100%, because we still use the law of gravitational attraction to figure things out. That equation hasn't been thrown away. It's still an accurate predictive equation, a mathematical law that we can use to describe the actions of things around us. You are right, and I even agreed with you at the start that Newton assumed it was an invisible force. But yes, Einstein said, no, it's not an invisible force. It's the warping of space-time.
Right, but one did supersede the other.
It still manifests within Newtonian physics that we understand as a force, because there's an acceleration.
So my question is, right, okay, so that's going to lead on to two questions. You just said the word force, so I'm going to have two questions now. Do you have any current citation that's supported by science that allows you to use Newtonian principles instead of relativity by Einstein? It's like a yes or a no.
Well, again, I wouldn't use one or the other.
But you're disagreeing with me that one shouldn't be used, and you're saying that you use them practically, mathematically every day, and I'm saying, have you got anything that supports that's current science?
Yes, all the equations that we use to actually figure out attractive forces. That is still Newtonian physics that we use.
Yeah, but respectfully, you've not answered my question. You've said yes, but I'm asking you to produce evidence that supports your assertion that current science allows you to use Newtonian principles instead of relativity by Einstein.
Bear with me. There's a particular paper I was reading. Let me just get it for you.
And whilst you're looking up that, I just want to play a little clip in the background. I'll give you a minute or two to find it whilst I'm looking some up, whilst I'm playing this.
Easy to find. And as we skim through this, I'm going to point out a couple of key paragraphs.
And there we have the limits of his research. He skimmed through the article and cherry-picked things that he thinks proves his point. I read the entire article, and the first thing to say to Lily is that this article should not be used as proof of anything. It's not a scientific paper. Just because it's on Scientific American doesn't really mean anything. It's not a peer-reviewed, tested and accepted proof of anything. It's an article, somebody's opinion. But I will break down what the article actually says. It's about the author's personal experience in understanding some of the things that Einstein said. It covers how Einstein figured out that gravity is not an invisible force, but the curvature of space-time that can change the locality of something, and how it relates to, and it's expands upon Newton's understanding of gravity. In short, it actually helps explain how Newtonian gravity is the what and Einsteinian gravity is the why. Yet, Newton didn't have a complete understanding.
So that citation there is similar to what you've just said, for which credit's been given. But what you didn't say is the key point that I made in my response video, which was that it snapped the wand in two by showing that curvature of space-time and not an invisible force gives rise to gravitational attraction. But my problem is that if you're going to say that, then we need some science to support that position. That, as far as I can see, the current science is Newtonian, is Einsteinian. And I'm assuming that you're going to come up with something, and I'm looking forward to seeing it. But if you haven't got anything at this point, perhaps we can move on, because I do want to talk about something that the ballers frequently talk about, which is the Cavendish experiment.
I will get the paper for you I was reading. I can't figure out where it is right now, but I will get that for you after this, and please remind me, because I'd like you to read the paper that I was on about.
Yeah, we can do it.
Yeah, let's move on and talk about the Cavendish experiment for now, but I will get that paper for you when I find it, okay?
What value do you put to the Cavendish experiment in terms of weight of evidence?
Well, can I ask you a question first? What do you think the Cavendish experiment was for?
To measure the density of the Earth.
Well done. That's better than most flat earthers.
Thanks. I have it literally on screen.
Obviously, most people, when you talk about the Cavendish experiment, just assume it was to figure out the G constant, but that was actually a byproduct of what he was doing. The validity of the experiment, I think, is very good, because it follows the scientific method. It has independent and dependent variables.
Hang on. What was the observed phenomena, though, in the Cavendish experiment?
Attractive force.
Okay. So how was that demonstrated in the experiment?
Because you could see that the weights moved towards each other when there was no other interaction. Okay.
I agree. That is what he's demonstrated. Would you agree or disagree with me when I state that there are videos on YouTube that go both ways? There are videos that basically some people say that you can do it, other people say that you cannot do it, and it's difficult to repeat. Would you agree with that?
I would agree that it's difficult to repeat, and this is why when Cavendish originally did his experiment, he did it over a year. I think even more than a year. And he took as many precautions as he could to try and limit any external influences on the apparatus and etc. He built a big box in his shed, and he used telescopes to measure the angles. Obviously, he didn't have lasers and stuff at the time, so the best way to look at the minute changes was to use a telescope and view it from the outside.
Sure. So in the Skype chat, I've sent you the link for the video that I'm just about to play for my audience. 4 minutes and 12. So go from 4 minutes, 10 seconds onwards. You get the professor that's describing how his technician has basically sawed this apparatus in half. And I'm going to read what he says. I'll get it on screen so that I can present it as well as... bear with me. There's another thing. He said, what I'm going to do is I'm just going to play it from 4 minutes 10. You might want to click the link and listen to it yourself if you'd like. That might be helpful for us both.
I think I can. If you play it, I'll be able to hear it now.
All right, okay.
The red balls inside there. This job really is very difficult to get to work, and a technician has sawed it apart, so we got so frustrated.
So he says that the experiment is really very difficult to get to work, right? He doesn't say the experiment's very difficult to demonstrate. He says it's very difficult to get to work. Now, that might just be a Freudian slip. But if it's very difficult to get to work for a technician that gets that pissed off with it, he saws it in half, what's the likelihood that the average viewer for YouTube that's trying to work out the truth what's the likelihood that they should accept people like Sly Sparkane or Miles Davis, when they repeated it in their bedroom when a university professor had to saw it in half because he was that frustrated with it because he, quote, couldn't get it to work?
Well, it is a very fiddly thing, and I mean the clip that you showed, the experiment's contained within like a plastic container, and that I think that particular one was a very small scale version of the Cavendish experiment, and that's going to come with its own problems. Yes, there is going to be issues with people trying to do this in their bedroom. You're not going to be able to get the same laboratory conditions, etc. The best one that I've seen at the moment of people trying to do it themselves is a guy called BM Verbal Pancake Hero, who is trying to take as many precautions as possible to remove any static attraction and any perturbations from air and everything. It's not an experiment that just everyone can set up because it's not that easy to do.
You're right. So if Dell in his shed was to do the Cavendish experiment in his shed, he's kind of repeating what Cavendish did, right? Would you accept
Be
it?
attempting to, yes.
Yeah. I mean, do you think that a bloke in his shed or some university professors that have got actual equipment that's specifically designed to do the job that gets sawed in half because he found it very difficult to get it to work, do you think that either seem credible in terms of making the point that this is repeatable? Because my position is that whilst you can go and find videos that do support it, you can find an equal amount that don't support it. And given how complicated it is supposedly to get it to work, the question becomes, how remote is it that this point is actually valid? So leading on from that, that's a rhetorical. My question that follows that is the value of gravity that's attributed in the Cavendish experiment. Are you familiar with what value that actually was according to his paper?
As in what he figured out G to be?
The force between the balls, when he was measuring this so-called movement between the balls that he was attributing to gravity. Do you know what how he quantified it in his paper?
I do. Barry, I've got it written down. Sorry, go on. Just explain.
I'm reading from his paper. I'll give you a copy of the link and I'll drop it in the Skype chat just for you. Hang on. I'm reading from his paper, which is it's the one that went to the Royal Society. It is a copy of his original paper. It's dated June the 21st, 1798. Now, this is really contentious because a lot of ballers say that I don't understand this, but I'm going to put it to you that I completely understand this, and I'm going to ask you to explain how I've either got it wrong or explain how it's explained. But at the bottom of page 2 of his actual paper, it reads, quote, "As the force with which the balls are attracted by these weights is excessively minute,"
yes,
right?
Yes.
The force with which the balls are attracted by the weights. So he's on about the lateral force between the weights. It's excessively minute. It's not more than a 50 millionth of their weight. It's plain that a very minute disturbing force will be sufficient to destroy the success of the experiment. So he has to take precautions and stuff.
Yeah.
But my question is, if he describes it as excessively minute and it's 50 million to 1 as a ratio, either can you tell me how I've misunderstood that, or can you tell me what was actually meant by that? Because I will assert that the force between the balls, as it says, is not more than a 50 millionth to 1.
Yeah, well, it's not saying that there's like a 1 in 50 millionth chance, obviously. What
Really?
it's saying is that the attractive force compared to the masses is very, very minute.
No, that's not what it says.
that-
No, that's not what it says. Let me read it again. I'll read it verbatim. It says, "As the force with which the balls are attracted by these weights is excessively minute." It's not talking about the mass. It's talking about the force with which the balls are attracted by the weights.
Yeah. So yeah,
It's not-
as
yeah,
the force with which the balls are attracted by these weights is excessively minute, not more than 1/50 millionth of their weight. It is plain that a very minute disturbing force, yes. So the force, but obviously, force is mass times acceleration, so we can still talk about mass because that's what force is. So yes, the force compared to what.
I'm sorry. Just, I don't mean to be rude, but I need to interrupt you there. Just give me the definition of force again.
It's mass times acceleration.
Right, that's a mathematical definition, though, right?
Well, yeah, but it's a demonstrable fact that that's how you calculate force.
No, that's how you calculate force.
Yeah.
Yeah, but how do you demonstrate force? I've got a definition on screen. It's a push or a pull upon an object resulting from the object's interaction with another object.
Okay, I
But
don't disagree with that. But
there has to be a push or a pull.
if I can just explain why the Cavendish experiment, what it did, the experiment was set up to exacerbate the gravitational attraction, to amplify it, to make it easier to measure. So when it says that the force between them is not more than 1/50 millionth of their weight, that is absolutely correct. And that's why it has to be done in such conditions that nothing can disrupt it. And this is why that Cavendish did the experiment over a year, taking multiple readings to make sure that what he was getting wasn't just results from disturbances and things. You are right that it is a very, very minute force compared to their weight, And
Right.
again, when you look at weight, that's mass times gravity.
Well, thank you for confirming that, because all the ballers tell me that I get that wrong. Now it's
Well,
clear that I'm
I
not getting
think
it wrong.
in the video that you originally did about it, you described it as a chance rather than a ratio. You actually described it as a 1 in 50 millionth chance of it being.
Yeah, like a probability. But
Yeah.
did you see the asterisk that followed it? Said that although it's not a probability, it's effectively the same thing in this context. I did distinguish it from a probability, but I agree with you. I did describe it that way. You're right.
Yeah. So
There was a
I mean,
footnote.
I won't disagree with you. The fact that it is a hard thing to do, and it is such a minute, thing that you need to measure, but that's why the experiment was designed in such a way. Using the torsion coefficient of the wire and everything to be able to calculate such a minute force. The whole thing
All right.
was set up to make it amplify so that you're actually able to measure it. But at the same
Right, so-
time, that would come with its own problems, because if you're amplifying the force, you would also be amplifying any outside influences. So I agree with you that it can be a very, very difficult thing to do and to do correctly. But when it is done correctly, all the measurements come out the same. You get
All right.
the value of G being what we know it to be, and it's always the same.
Well, it is the thing. I'll give you Cavendish, right? You can make whatever assertion about it that you want. When we go back to the current science, it literally says the words, and I'll quote it again: general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. So I'll give you that your invisible force that Newton predicted or talked about, I'll give you that the Cavendish experiment demonstrates or shows that. However, current science doesn't maintain that that's the current position. It says that it's no longer, it specifically expressly denounces it, not an invisible force gives rise to gravitational attraction. Again, the problem with that is we're back to the maths that makes it theoretical physics. And by sheer coincidence, we've got a Scientific American document, which I'll give you a copy of in your Skype from right now. Hang on. Which basically says that theoretical physics is pointless. And by coincidence, the article happens to have a picture of Einstein in it talking about relativity. If anybody's not seen this in the chat, go and have a look at it, because it talks about string theory that also came up. But my point goes back to this. You can have Cavendish, right? You can claim that it proves whatever you want. If Cavendish has been superseded by Einstein with relativity, and Einstein puts a mathematical concept, which we know by definition is conceptual, we know it's a reification fallacy if you treat it as though it's real world. What value does it have when it's not capable of experimental application because it's maths?
Again, I disagree that you cannot use the two together.
So you're
right. All right, if you want the way that he described it is snap the wand in two to say it's not an invisible force. And I started with agreeing with you with that. That's how Newton saw it, because that was how he could measure the acceleration, and acceleration requires a force. But Einstein explained that it was not an invisible force. It was the warping of space-time. But that doesn't mean that you can't measure it as a force. Because within Newtonian physics, it manifests as an attractive force.
Of course it does. You can't measure it as a force if it's mathematical by nature.
Well,
listen,
you can still measure the force, Anthony. You can still measure that there's a downward acceleration of 9.8 meters per second squared. You can still measure the attractive force between any two objects in the universe using Newton's law of gravitational attraction. That's not something that can just be thrown away. It's a mathematical law that has been proven time and time again to be fact.
But you can't calculate, you can't measure a force when you can't demonstrate that there's an interaction between the two objects. Because this is where it starts getting a little bit scientific method, right? You're obviously familiar with the scientific method, right?
Yes, very much so.
Do you agree that you've got to manipulate your independent variable to prove that it is the cause of the effect that you believe that you're witnessing?
Yeah, and that's what the Cavendish did. So the independent variable within the Cavendish was the distance between the weights.
All right, so
you manipulate the weights, the distance between the weights, and that manipulates the gravitational attraction between the weights.
Do we agree that when you manipulate your independent variable, that is your presumed cause? So if you're going to vary the distance between the weights, that would be your cause. But if you're trying to prove gravity, which he wasn't, he was trying to measure the density of the Earth. But if you're going to use it to say that he was trying to prove gravity, he has to manipulate gravity as his independent variable, correct?
is manipulating gravity. Well, he's manipulating the gravitational attraction because the inverse square law. The closer something is, the stronger the gravitational attraction is going to be. So
right,
by manipulating the distance between the weights, you literally are manipulating the gravitational attraction between the objects.
No, you're not. You are inferring that there is a cause there, but you're not manipulating the cause. You're correlating the effect that you believe you're witnessing, and you're correlating that with what you presume is your wiggling. And I'll give you an example. Every morning the sun rises at whatever time. 10 minutes before the sun rises, a rooster crows every morning, right? And every morning you notice that seems to be a pattern that the rooster crows just before sunrise, and then the sun rises, and you think in your head that correlation that you're witnessing is actually the cause. And you think that the rooster's actually causing the sun rising because every single morning, without fail, the sun rises just after the rooster crows. But then the rooster dies, and then the sun still comes up. So what you've witnessed is a correlation that you think is causing the sun rising, but it isn't actually doing it real world. So your claim of moving the weights to and from, or closer and further away, is a correlation because you're not manipulating the actual cause, which in this experiment wasn't even gravity, but let's just say it was. If you're going to prove gravity is a thing, you have to manipulate your independent variable being gravity, not the correlation, not the interaction or proximity. You've got to wiggle that gravity to prove that it is the cause of the effect that you believe that you're seeing. Do you disagree?
Again, you are manipulating the gravitational attraction by changing the weight. The closer something is, the stronger that force is going to be, the more acceleration towards the object there's going to be. You are manipulating the cause. You are trying.
You're not.
Because you can have the weights at different distances between them, and that will give you a different gravitational attraction based on how far away they are. But you'd always get the same for G because it's based on the distance between the centers.
Right.
I mean, what we're arguing about here is semantics, whereas what we should be saying is, if you're saying gravity isn't a thing, then you need to show me or tell me why things fall and accelerate.
Well, hang on. That's a straw man at this point.
No,
it's a red herring.
It's not a straw man. We have an understanding and an explanation for why things accelerate towards the ground, and that explanation is gravity. It's an observed fact that things accelerate on Earth at 9.8 meters per second squared. Wherever you are on Earth, you have that downward acceleration of 9.8 meters per second squared acting on you. And we attribute that to a force that we call gravity. And if you're trying to say that it's not gravity, you need to present something else. And all you're doing is trying to dismiss the experiments and explanations of what we think gravity is without actually offering an alternative explanation. So I have to ask you, Anthony, why do things fall? More importantly, why do things accelerate?
Right, hang on. We've already... I'll come to that in a minute, but you've made about 4 points there, and we did agree that we weren't going to, scattergun.
Sorry, I kept it to just one. I apologise.
Let's take it just step at a time. You say that this manifests itself as a force, correct?
Yes.
So when you have the word force, we're going to have a meaning for the word force, right?
Well, a force pushing or pulling, or described mathematically as mass times acceleration.
Yeah, and an interaction is one of... there are numerous definitions for the word force, and you can pick any one. I've just got on screen, or I did have on screen, bear with me, the definition, or a definition of force. But in the definition of force I've got on screen, it's got the word interaction. It's italicized, meaning that emphasis is given to that particular word. And it just says a push or a pull on an object resulting from the object's interaction with another object. But if you're going to claim that gravity is a force, even though I've demonstrated that it's not the current science and it's mathematical and it snaps the wand in two and all that, and I'm prepared to concede this point as well. So this is kind of academic. But if you're going to say that it is a force, then what's the interaction between the other object? Because the interaction must be the gravity, right? That's your assumed cause, your presumed cause.
Well,
right.
Of course, when you're talking about the attractive force, it's between the two objects. Both objects are attracted towards each other. As much as we're attracted towards the Earth is also attracted towards us.
Okay, so I'm going to cite words from a PhD level physicist called Anne-Marie Hemmenstein. I'll give you a link in the Skype chat now. Bear with me. Paste that there. She reads that words of precise meanings in science, for example, theory, law, hypothesis, don't all mean the same thing. Outside of science, you may say that something is just a theory, meaning it's supposition that it may or may not be true. In science, a theory is an explanation that is generally accepted to be true. It talks about all the words, but the point that this citation is making is that words do have meanings, right? And to further make that point, I saw PMARS, for example. He had on screen the definition of natural, and he was trying to use it against Nathan. One point for mentioning this is that when it suits the ballers, they will cite definitions to be important. But when I try doing it, you said that it became a semantical argument. Now, my question is, if it's going to be semantical and you're prepared to dismiss it, bearing in mind it is the subject of what we're talking about right now, gravity, this interaction, then it's not going to be semantical when it's pivotal to the point that we're trying to conclude. That if it is a force, even though, and I'm prepared to concede this, by the way, but if there is a force there, you've got to demonstrate that there's an interaction between two other objects, right? So my point is that if you're going to say proximity of the weights to the balls was the independent variable, I'm going to say no, because that wasn't the presumed cause. The presumed cause wasn't proximity. The presumed cause was the force between the balls. But you've got to demonstrate that force by wiggling it. So we've been pushing this for a while on Nathan's, and it is the reason why Nathan fell out with Bob. I'm sure you're well aware of it.
Oh, yeah.
If you can't manipulate your presumed cause within a scientific experiment, you get a correlation, or at worst, you get pseudoscience. So if you're going to say that there's a force there, words have meanings. So is it right that we use the force in its normal meaning? In other words, that there's something there that we can show that actually exists? Or is it right that we just presume that there's a cause there and think that we can prove it by experimentation? But when we do an experimentation, we don't manipulate the independent variable. We substitute it for a correlative effect rather than a cause.
Right. So when I say a force, I mean something we can physically measure.
Yeah, that's what I mean.
And do you deny that we can physically measure the attractive force between things?
Absolutely, yeah. No. The attractive force between things, I deny. We can measure stuff, I agree. But I'm just citing the current science, which states that it's not... don't forget, I'm prepared to concede this point. I'm just citing the current science that says that relativity snapped the wand in two by showing that it was curvature of space-time and not an invisible force that gives rise to gravitational attraction. I'm prepared to give you that Cavendish. You can have Cavendish. What I'm saying is that if you're going to claim Cavendish as proof of something, will you at least agree with me that there's no independent variable to manipulate your presumed cause? Because all you're doing is varying the proximity of the things, and you're inferring that there's a force there that we can't observe because nobody can repeat it, but you're not actually proving it because you're not wiggling it. So what I'm saying is, I'll give you Cavendish if you agree with me that he doesn't manipulate gravity, he manipulates the proximity only, and it's inferred.
It's not inferred, no. It's a measurable attraction. That's my point here, is that
I get your
force
point.
of gravity is a measurable thing. And within the Cavendish experiment, the independent variable of the distance between the weights was manipulating the gravitational attraction between the two objects. So by manipulating one, you are manipulating the other. The gravitational constant is never going to change. That isn't something you can physically turn up or down to try and manipulate. But what you can do is manipulate how much that attractive force is happening, which is why you have to wait for the Cavendish experiment to reach its natural equilibrium and then introduce something else.
Listen, I get your point. I understand it. I'm not sure you get mine. Your independent variable has got to be manipulated, right? You're saying that proximity, the distance between the two objects, is the cause. Distance is conceptual. It's a man-made construct of units that we call millimeters, centimeters, feet, or inches, or whatever. It's not. It can't be a cause. Distance can never be a cause of something. Yes, you might get a correlation, but you can't have cause because distance, it's like speed is never a cause. Yeah, there might be a correlation, but you can't manipulate these things to prove the cause and effect relationship.
Okay, I'm going to present let me ask you a question then. If you were to take two magnets and move them towards each other, and then they clip together, what did you do? What did you do to manipulate what was going on?
You move two magnets.
Yeah, so I'm just like, sorry, I'm trying to get it across in a certain way. So if you wanted to show that magnetism was a thing, okay?
Right, so you put a piece of
magnets on a table next to each other. All right?
Yeah, so
you can't manipulate the magnetic force that each object has. But what you can do is manipulate the magnetic attraction between them
That's
by
not true.
changing
That's
the
not
distance.
true. That's not true. You can get two magnets, you can put a piece of paper on them, sprinkle ion filings on them, and it'll show the interaction between the two, right?
Yeah.
Everybody accepts that. If you want to manipulate the force between the two, just pass something copper or something like lead or whatever to disturb the field between the two objects. And then you can demonstrate that you are manipulating that force between the two magnets with the ion filings on the top. So that can be done. That's not true.
You wouldn't be manipulating the force.
By using something else in the middle, yeah, you would. You'd be making the field lines go around it or going through it, depending on whether it was ferromagnetic or not. So we can demonstrate the magnetism.
And you can manipulate the distances between them, and that will change the magnetic, force of attraction between them.
Right, but I'm not manipulating the distances. I'm demonstrating the force and the interaction between the objects with ion filings.
Okay, and so how is measuring the force of attraction not the same?
Well, how are you demonstrating that there's a force there when there's no interaction? There has to be an
acceleration. We know there's a force because force requires.
All right.
Sorry, acceleration requires a force. So we know there is a force there.
All right.
We're not just making this up. A force is a physical thing that can be measured. And
okay.
We are measuring an actual physical attraction.
All right, so basically F equals ma, right? You're going to say that because something moves, therefore there must be a force, right?
Yes.
And you're going to attribute that force to be gravity, yeah?
Well, we can call it what you want. You can call it Fred if you like, but
all right,
it's still the same thing. It's still an attractive force between two objects that can be measured.
So what about Newton's third law of momentum? Are you familiar with that?
Newton's third law of motion?
Yeah.
Every action has an equal and opposite reaction. Yeah, very much so.
So what's the equal and opposite reaction if you've got a force that's being pulled one way? What's the equal and opposite reaction in that example?
Both objects are being attracted towards each other. One object is attracting towards one and the other object is attracting towards the other.
They're the same. They're the same. So what's the equal and opposite reaction?
1 second.
If there's a force pulling the weights together, there's got to be an equal and opposite force pushing them against each other, right?
1 sec, sorry.
Whilst he's away,
sorry, I'm back.
Okay.
Right.
So, if there is an equal for every action, there is an equal and opposite reaction. What is the equal and opposite reaction in the Cavendish experiment?
The measurable force, one, like I was saying, both things are attracted towards each other. There's an equal and opposite reaction with when you actually do the maths for how much one is attracted towards the other, it balances out, showing that the forces are equal and opposite.
So you got one of the forces is the gravity that's pulling the balls together. What's the equal and opposite reaction that's the opposite of what you're seeing?
Like I said, the both of the forces acting on each other balances out and is equal and opposite.
Both of the forces? What is there a second force involved?
Sorry, when I say both the forces, the force of attraction between M1 and M2. Okay, they balance out and it's equal and opposite. Sorry, 1 sec, my daughter's crying. I'll be back in 1 sec.
Okay. Well, whilst he's dealing with his daughter crying, I'll just quickly demonstrate a couple of definitions for the independent variable. This is the bit that a lot of ballers refuse to acknowledge. Independent variable, the variable which an experimenter deliberately manipulates in order to observe its relationship with some other quantity, which defines the distinct conditions in an experiment. Are you back?
Yep, sorry, I'm back. Yeah, so my point is that gravity affects both bodies. Okay, when you do the maths for the attractive force between them and the distances, the forces balance out because there is equal and opposite of everything that's going on.
Right, so I'm asking you to specifically identify what is the equal and opposite reaction if there is a force of attraction pulling the objects together. What's the equal and opposite reaction in that demonstration? Physically, what is it?
The fact that both things are attracted towards each other.
No, that's the force of attraction. That's the one way. I'm asking where the second part of it is.
The other mass being attracted towards the other mass. That's what I'm trying to say.
No, but that's rotating
for the equal and
around a
opposite,
pivot point.
everything
That's
has
the
to
same.
balance out. Okay, and
No,
when you do the maths for the actual attractive force between the objects, you get an equal and opposite force on each side. The sum of all the forces balance out to zero.
Yeah, but they're both rotating around a pivot point. That's essentially the same force. One force doing that same movement on both sides.
Okay, if you want to talk about, let's say, for instance, in the Cavendish experiment, all right, the equal and opposite force of that is actually the torsion in the suspending wire. Okay, so within the Cavendish experiment, you've got an attraction.
But if it's hang on,
let me explain. Within the Cavendish experiment, you've got what we're measuring of an attractive force between the masses. Okay, and as that attractive force happens, you get a torque on the wire. Torque is force, but for twisting, right?
Yeah.
And you can calculate the torsion coefficient to figure out the force on that wire, which is equal and opposite to what's happening with the attractive force between the things. Now,
however, what you're describing is not an equal and opposite reaction. You're describing a resistance.
I'm describing a force.
No, a resistance. That's not an equal and opposite.
Torque is force for twisting.
But you're describing a resistance. Force. You're describing a resistance. I'm asking for what the equal and opposite reaction
is. Resistance. I'm telling you that the equal and opposite reaction is the torque in that wire, the actual twisting of the wire.
Right,
that
but
is
I'm putting it
force
to you
to the gravitational attraction, and
I'm putting it to
the
you
sums
respectfully.
balance out to zero.
Well, you know when you said to me before that you disagree with me over the bending of space-time snaps the wand in two by showing the blah, 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 and I asked you for a citation for it. I'm going to put to you now respectfully that there is no equal and opposite reaction in the Cavendish experiment, and that contradicts the third law of motion for Newton.
I've literally just explained to you what the opposite force is.
The
resistance,
and you've demonstrated
as you
a
call
resistance.
That is a force.
You've demonstrated a resistance. That's not a force.
Are you trying to say that torque isn't a force?
I'm trying to say that the resistance of the torque line is not a force.
But torque is a force, Anthony. That is literally the description of torque. Torque is force.
Well, it's not in this
twisting.
context. It's a resistance on the wire, isn't it? That's not a force.
Yes, it is a force because you're creating a torque. Torque is a force.
I don't agree with you, but we can move on. I'll just give you it for the sake of moving forward. You can have. I'll concede the Cavendish point. You can have Cavendish. You can say that it proves whatever.
Okay,
but we still go back.
Can we move to the main question around gravity? If you're saying that gravity isn't a thing, then you need to try and replace it with something. It's fair enough trying to dismantle the argument.
That's a logical fallacy of debate called reversing the burden of proof.
No, that's what you're doing there is just you're doing the fallacy, Anthony. You're just calling everything fallacies. All right. We have an explanation. We have a mathematical model that makes sense and makes predictions. You can call it what you want, but we can demonstrate that there is an attractive force.
No, you can't. Because you can't. I'll give it you.
Wait. You've agreed. You've given me the Cavendish experiment.
I'll give it you.
And the Cavendish experiment demonstrates an attractive force with an equal and opposite force in the torque of the torsion wire.
No, it doesn't. What the Cavendish experiment does is determines the density of the Earth. It has
that was the purpose of the experiment. You're absolutely right.
Right.
But what's happening?
He's not demonstrating gravity. He's determining the density of the Earth. That's literally what he's doing.
Yes, you're right, but that doesn't mean that it's not also doing the other thing.
Right.
The Cavendish experiment quite clearly shows an attractive force which can be measured by the torque in the wire.
Listen, it doesn't quite clearly do that at all.
It does. We've just explained how it does. You cannot
I don't care how you explain
that torque is a force.
Listen. I don't care how you explain it. I'm happy with what we can prove or not prove, and it's clear that it's disputable about whether it does or does not show it. Because I
100% disagree that it's disputable because there is a measurable force happening.
All right, so you say, and I'll give it you just so we can move on. You can have it.
Right.
However, it doesn't change the fact that Newtonian principles for gravity are antiquated science, and it's been replaced.
You should probably tell all the equations, all the people that use the equations for things around the world.
I'm trying to. That's why I'm bringing it up to you right now, so that you're aware that the current science replaces Newtonian principles. It doesn't add to it. It doesn't refine it. It doesn't manifest itself as a force. It replaces it. It snaps the wand in two. So what I want you to do is at least acknowledge that this current science on screen right now, you've got nothing to counter it, And if it snaps the wand in two, you shouldn't be pushing the Newtonian principles or anything other than antiquated science.
No, I disagree, because it is a continuation. It is an expansion of Newton's understandings. Newton didn't know about space-time. He had no idea that space-time was a thing.
Listen. Anne-Marie Hemmenstein, PhD, says that words have precise meanings in science.
Okay,
the current science
we're not going to go around arguing about words, Anthony. We're going to talk about physical things.
Yeah,
right?
Not physical, is it, though, is it?
It's not because there's a physical force that can be measured. The torsion of the wire in the Cavendish experiment.
Einstein
the attraction, the acceleration. Acceleration.
Einstein says that it's... Einstein literally
let's just
says
get down to the very,
white.
very basics of gravity, Anthony, all right?
Right.
Acceleration requires a force. Do you deny that there is acceleration on Earth?
Listen, Einstein literally says...
No, come on. I want a question. I've answered your questions. I want a question answered now. Do you deny that there is a downward accelerating force on Earth?
You can't prove it.
I absolutely can, because there's acceleration. Acceleration requires a force.
So F equals ma. You're back to Newtonian principles, right?
Please, just wait. Answer the question, Anthony. Do you deny that things fall on Earth with an acceleration of 9.8 meters per second squared?
Only in the medium of air.
Yeah, okay. But do you deny that that accelerating force is active on you, whether you're in air or not? You can be falling through water, but you still have a downward acceleration of 9.8 meters per second acting on you. But then you're encountering the buoyant forces that are creating an opposite force, making you fall not quite as fast. That downward acceleration of 9.8 meters per second squared is still there.
Craig, it's not a force because you can't demonstrate there's any interaction.
Anthony, acceleration requires a force.
Only according to Newton. But we know that Einstein... Wait. Are you trying to deny that acceleration requires a force? Absolutely, that's my point.
Oh my goodness, there we have it. That is literally the most stupid thing I have ever heard.
You've got it in
of course acceleration requires a force. Otherwise, how do things accelerate?
It's not my fault that Einstein snaps his wand in two, mate.
We're not talking about Einstein right now. We're talking about what a force is. Okay?
No, I'm talking about current science.
That acceleration requires a force.
I'm talking about the current science, and you're dismissing the current science and going to antiquated
the current science. I'm making it clear that you don't really understand the current science, and you are nicely avoiding my questions, Anthony. I've answered every single one of yours, but you are just talking in circles around my questions.
Because it all leads back to the same point.
Acceleration requires a force. This is a physical law that cannot be denied. We know that things need a force to accelerate. We know you have to put fuel in your car to make it go faster. We know that you have to punch something with a force to make it move and accelerate. We know that you have to put force into the ball when you throw it to make it accelerate. Acceleration requires a force. There is a downward acceleration on Earth, measurable, of 9.8 meters per second squared.
It's antiquated science, and why are you reciting it when I've just said to you, I'll give you the Cavendish, but you've got to give to me...
Cavendish right now. I'm talking about acceleration.
Yeah, that 9.8 meters per second is relative to the medium in which you're in. It doesn't require a force. That's what Newton said. Newton's theories were replaced by Einsteinian's relativity, a point that you seem to be ignoring and reciting back to.
You're ignoring what I'm saying, that acceleration requires a force.
It doesn't, though, does it? It just requires a disequilibrium between the medium the thing is in and its own density.
No, that would not make an acceleration. Why would it speed up, Anthony?
Because of the disequilibrium between the medium it's in and its own density.
Right, so you're trying to attribute the reason why things fall to density and buoyancy?
No, relative density.
Right, well, that's completely stupid. Because...
we can demonstrate
let me explain why.
Go on, then.
If it was to do with relative density, all right, as things fell, they would decelerate because the atmosphere is thicker the closer you get to the ground.
No, the only way it would decelerate is if the medium it's in gradually got more dense.
And it does.
Which is what we observe.
The medium of the air is more dense nearer the ground. So,
correct.
If things were falling and due to relative density, they would decelerate as they got towards the thicker medium.
That's exactly what happened with Felix Baumgartner when he started off on his stratospheric jump. He started off doing Mach 2, apparently, according to the so-called science. But because of the so-called air resistance, which just so happens to be an increase in the density of the atmosphere, he slowed down to about 600 miles an hour from Mach 2, apparently. So that is exactly what we observe.
And that would be because he was moving from not much atmosphere to an atmosphere that then created a terminal velocity.
Which was the point that I was demonstrating.
A re-entry, right? But
yeah, but you said that it would slow down as it got into a more dense material, and that's what I've just demonstrated according to the Felix Baumgartner scientific jump. That's exactly what happened. He started off at Mach 2 and he dropped down to 600 plus.
And then what happened to that?
Well, he pulled his parachute and landed, I guess.
Yeah. Okay. So if you're in Earth's atmosphere and you drop something, what happens?
Yeah, but your point was that it slows down as it gets from the more dense, the less dense to the more dense, and I've just given you a demonstration or a citation for where that actually did happen, and you're, rather than crediting me with it, you're then trying to do something else, and you should credit me.
I'm agreeing that. Sorry. One sec. I do apologise, my daughter again. Bear with me.
All right. And whilst he's away, I think it's clear that he's going to still cite this mathematical, the Newtonian principles for being current science, even though they're antiquated. And he should be moving to Einstein, but he's still going to stay with Newtonian principles.
Right, sorry, she's crying in her sleep. Right, okay, so. Right. Things accelerate as they fall in Earth. We know that. They will.
They don't always fall, though, do they? Let's be honest.
Well, if you're talking about buoyancy, then no, things will rise, but that's still because there's a downward accelerating force on them.
No, it isn't. It's because its relative density to the medium it's in is greater than or less than.
What's the equation for buoyancy?
What's that got? Right, if we're going to go down mathematics, then we may as well go down Einstein. Are you going to accept Einstein?
No, because mathematics describes physical things happening, Anthony.
Right, listen, I'm aware that little g appears in the definition for buoyancy. My point is not that that's relevant. My point is that it's relative to the medium in which it's in. So if, for example, you can have an anvil, a big steel or iron anvil. You can drop it in a tank full of, what's it called? Not liquid metal, what's it called?
Mercury?
Mercury, yeah, and it'll float.
That's because mercury is pretty dense?
Yeah, that's right. But that's my argument. Your argument is that there's a downwards acceleration force that magically converts into an upwards acceleration force called buoyancy.
Not magically, not at all. You have to have that downward acceleration for there to be a buoyant force acting in the opposite way.
Only in maths, Craig.
In reality, because maths is reality, and
maths is not reality.
But we can describe our reality with maths.
Craig,
maths is the only language that you can describe reality with.
Right, you can describe reality, but maths is not reality.
I disagree.
Listen,
maths is 100% reality.
Craig. All right, I'll prove to you right now that maths is not reality. If I've got 2 ice creams in my hand, you can't take 5 ice creams off me and leave me with -3 ice creams, can you?
Say that again.
If I've got 2 ice creams in my hand, you can't take 5 ice creams off me and leave me with -3 ice creams, can you?
No, because you didn't have them to start with.
So maths is not reality then, is it?
No, but I could take 2 ice creams off you and you wouldn't have any.
Yeah, but you can't take 5.
What
you can't take 5 and leave me with -3, can you?
Because -3 isn't a thing.
Right, so maths
I
cannot be reality.
The value of those things off of you. Maths will accurately describe what is happening.
No.
Yes.
In real world, listen, if I've got 2 ice creams, maths can describe that you can take 5 off me and leave me with -3. But that's not reflecting real world, is it, Craig?
Yes, it is. What you're
Craig,
what,
you can't take 5 ice creams off me.
Adding things in that aren't there. Maths will still describe that correctly. I could take the two ice creams off you and leave you with 0 ice creams. If you had 5 ice creams, I could take 5 ice creams off you and leave you with 0 ice creams. You never had. If you have 2, you don't have 5 ice creams for me to take away. So I can't do the maths to describe that. What you're doing, what you're doing is a straw man here, Anthony.
No, I'm
you're
not.
Trying to attribute something to something that there isn't.
No, Craig,
yes.
Your claim is that maths is reality.
And
I've just demonstrated that it isn't, and you're still holding on to it, and you should be conceding it.
Because you are misrepresenting what actually maths is.
What? So 2 minus 5 equals -3 is actually a misrepresentation.
You've got -3 ice creams now, Anthony. Well done.
No, I don't have -3 ice creams. I have 0 ice creams, Craig. Maths is reality.
That's -3 if you want to take it like that. But
no,
maths
I'm trying to demonstrate
what
that it's
happening.
not reality, Craig. You should be conceding this.
No, because you are not right. Everything that happens in the universe can be described with maths.
It's
Every
not
single
reality,
thing.
Craig. Look, I've got 2 glasses in my hand. They're both pint glasses. If I put the 2 glasses now down, I've now got no pint glasses. But you can't take 5 pint glasses because there aren't 5 there. But only in maths can you do that, Craig. You've got to concede that point.
No, because if you had 5 glasses, then I could take 5 glasses off of you.
Craig.
Anthony, what you're doing is a straw man. Okay,
No,
you
you're a
keep accusing
scrimshank.
me of straw manning, but you are completely straw manning now. If
Craig.
you had 5 glasses in your hand and I took 5 glasses away, there would be no glasses left.
Craig, you're scrimshanking me, aren't you?
No, I'm not at all.
You are.
Everything that happens in the universe can be described with maths.
I'm demonstrating that your maths description isn't reality. It's only in maths is that possible, right? That's not reality, Craig.
That's because you didn't have 5 ice creams, Anthony.
Correct. So maths
Right?
is not
And
reality,
the
then,
maths,
is it?
The maths isn't making up these extra ice creams. You would
Correct.
never do the maths.
Correct. That's my point, though, Craig. That's my point.
You're right. My point is that maths describes reality because it can
No, it doesn't,
describe
Craig.
how you can take 2 ice creams away. Maths can't add something that isn't there. What you're doing in your example is adding things that aren't there and saying that I can use maths to take them away. And that's not how it works. Maths will describe
Maths is not
what is
reality,
happening.
Craig.
Anthony, maths will describe what is happening. Maths will describe reality, and it is the only language that can describe reality.
Okay, do you mind if we change topics?
Yeah, I still want to get back to the reasons why things fall.
I've just explained that.
This
Relative
whole
density.
thing is completely wrong.
Okay, but we can demonstrate it, though. Have you not seen Nick from Phuket Word's egg demonstration in
Yeah,
salt water?
that was brilliant comedy. Right.
Yeah.
Let me explain the simple problem with your density thing, Anthony.
Go on, then.
That there is a pressure gradient in our atmosphere.
Okay.
All right. So if things are going to fall through a less dense medium, when you let go of something, they would go up. Because that's where the less dense medium is. All right?
Run
There
that by
is-
me again. Run that
Right.
by me again.
There's a pressure gradient in our atmosphere going from 14.7 psi to 0 psi. If you
Yeah.
are asserting that things fall because the density difference, then they would go to the path of least resistance where things are less dense. And
No,
that
the
would mean...
seeking. No,
that
no,
would
no,
mean
no. The
that they would
seeking.
go up and not down.
No,
Because
no.
that's where the less dense medium is.
I have no idea where your logic comes into that, but let me explain it to you simply. An object will find its equilibrium if it's free to do so. They all do it. That's why gas. That's why hot goes to
What's
cold.
the equilibrium? Why is it going down?
It's relative to the medium it's in.
Yeah,
so
but why
for
is
example,
it going down? Where's the vector coming from?
Okay, so the vector is caused by the density, the medium itself. So let me show you on screen. Bear with me one sec. All right, so this is a good citation that I use frequently. Have you seen this before?
I don't see what you're presenting.
I'll send it to you in the side chat.
Wait, one sec. I'll open your...
It's all right, you've got the link in the side chat, in the Skype chat.
Right, oh, yeah, right, the density tower, yeah.
Yeah. So we'll take the cherry tomato that's in the middle, just
Yep.
because it's in the middle and it's a solid. Now, what we can do is we can use any of these layers, liquid layers, and we can give them a value, right? We can call them numbers. We can call them anything that denotes like a rank. So you can call it, say, 6 and then not put units to it. Or you could put units to it and we can call it unicorns. But we know that it's sat in a relative position relative to the mediums that are around it. Let's give the cherry tomato, say, 5. And the medium above it is 4 and the medium below it is 6. We know that that cherry tomato finds its equilibrium at the state 5 that we've called 5.
Why?
We know that if we take the cherry tomato out and put it back in again, it's going to go back to the same place. It's not going to be in 6 or 4. Sorry, it's not going to go 6 or 4. It's going to go back to 5. Agreed?
Anthony, that's a gradient of pressure.
No, it's a density gradient, Craig.
Yeah, and what's it caused by?
The density itself. All the relative densities relative
What's
to
density?
themselves. Pardon?
What's density?
the amount of matter in an object.
Is density a force?
It clearly is a force. You're literally looking at it. You're literally looking at it right now, Craig. It's literally
Right.
this
Here's
equilibrium.
the problem, Anthony. What you're saying is so silly because there is actually no vector. Why does that thing decide? Why do those layers decide to go in that particular order? What is telling those layers that they need to sit on those density sections? What is telling that cherry tomato to go to the particular level of density that it needs to? You are missing the vector. Density is not a force. That is the funniest thing I have ever heard.
Really?
Yeah.
So the vector comes from the fact that the cherry tomatoes, given the value that we call density is 5, the medium above it's 4, the one below it is 6. That is where the vector comes from. It's relative
Okay, but
density.
why are those layers in that order?
Because of their own density.
Why is one density sitting on top of the other and not below it? What makes those densities decide to be in that order? Where does that vector for each of those densities come from?
Do you understand what the phrase ipso facto means?
Stop strawman and answer the questions.
I am doing. Do you understand what ipso facto means?
Explain.
It means by that very fact. The density comes
and
from
by that
its
very
own
fact,
density.
you are missing the entire point, Anthony. Those densities, those layers of density, they need a force to be there.
No. They don't need a force to be there. They just need to be in a state.
Right, you've just described density as a force, and now you're saying it doesn't need a force. So which is it?
No, I'm not. I'm saying
yes,
that
you are.
these
Don't
density
backtrack.
towers.
Come on.
No, listen. These density towers that we can create all have relative density to them. By virtue of that fact, ipso facto is where you get the segregation from. Your claim that it's not got a vector is false.
No, it's
you believe
not, because those densities need a reason to be in those layers.
Yeah, the reason's density, Craig. You're literally looking at it on
Density
screen.
isn't a force.
Yeah, it clearly is. It's a disequilibrium force.
No, you're wrong. There is no density.
Well,
is
in
not
your
a force,
opinion,
and it's simple as that.
In your opinion, but
no,
when
not
you
my opinion. In a fact, in the universe, density.
No.
Density is mass per unit volume. That's what density is. That's all.
Yeah.
There's no
So
force
what?
in there.
So it doesn't matter, Craig. The point is, you're saying that I'm wrong, right?
Yes, I'm telling you exactly why you're wrong.
Well, your reason
That
for doing so is
density,
because
that density tower could not exist without gravity. Gravity is the
Bullshit.
reason that density tower is there.
bullshit. Your claim
Not
is
bullshit,
based on the
because
lack of a
density is
vector.
mass per unit volume. It's not a force.
Craig, your claim is that it lacks a vector to denote the direction. Correct.
Right, answer this.
Hang on.
What happens when two pressure transducers at opposite ends of a vertical sealed pipe? Why is the pressure greatest at the bottom?
Ask me again slowly.
All right. If you have two pressure transducers at opposite ends of a vertical sealed pipe, why is the pressure greatest at the bottom?
Probably because of the weight of the fucking the air in the tube above
what's
it.
Weight?
What's weight? Oh, are you going to go with the mathematical definition or the real world?
The actual definition of how we can figure out what weight is.
All right, so I'll change the word weight then to mass. The mass of the air above it.
No, sorry, but they're different things. Because
Yeah, I know, that's
is
why
mass
I'm not
times
saying-
gravity.
Yeah, but if
weight
you're gonna
isn't mass. You don't
Yeah,
have
but
a
I was-
weight, Anthony. You
Yeah,
do
but
not
listen,
have a
Craig,
weight.
I was using
you
weight
have a
in the
mass,
colloquial sense.
and that mass has a force acting on it, and that's what
Craig,
your weight is.
I was using the word weight in its colloquial sense, but you're asking me to define it mathematically, which has got little g in it, and I'm not going to do that. I'm going to say it's the mass of the air, the column of air above it. That's the answer.
Right. Okay. So why is the air above it pressing down?
Because it's more dense than the air that it sits in.
No, the air above it is less dense.
Yeah, so it's more dense than the air. That's why it's pushing down.
Why? Why is anything pushing down?
What's the definition of down in gravity?
If you want to talk about down, for us, it's towards our feet.
Towards your feet.
Yeah, down, Anthony. We all know what down means.
Yeah,
right?
but hang
No
on. There's
matter
an
where
issue
you
with
are
the
in
word
world,
down.
Down is
No,
Craig.
Craig. There's an issue with the word down. Well, hang on. There's an issue with the word down, Craig, because if you're going to use the word down, I need to know in which context are you using it.
I am
because
using
the word,
it as in down is towards Earth.
Right, center of the mass.
Yeah, I didn't want to use that because I knew you would have a problem. I'm trying to keep it in terms that we can both agree with, that down is towards the Earth. You know,
Right, but
we
the
don't
problem
have to talk about center of masses right now. All we have to agree that down is, say, from your head to your feet.
Yeah, but the problem is, if we agree that down is from your head to your feet, you're applying that down is like relative to Earth.
Well, it's relative to you.
So a subjective down.
No, down towards the Earth. I mean, it's going to be relative for
an
you
objective
wherever
down.
you are on the Earth. Down is always going to be towards the Earth.
Well,
Whether
here's the problem.
it's flat or round, down
Here's the problem.
is the direction things go.
Here's the problem. I've already demonstrated several times, and I know that you don't accept it, but I'm still going to stand by it, that Newtonian principles are gone in terms of this gravitational discussion that we're having. It's been replaced by Einstein. I know that you don't agree with it, but that is the current science. The problem we have with Einsteinian is that down is defined by the direction in which time passes more slowly, according to Einstein, which is the current science. So if you're going to claim that there is a down, and you're going to say it's towards Earth or your head or your feet subjectively or whatever, I'm going to say that that's not even the current science either. I'm going to say that down's defined by the direction in which time passes more slowly. So in this context, that's Einsteinian that replaced snapped the wand in two. What on earth are you talking about when you say down?
Okay, if you're talking about the time going slower, that's all to do with time dilation with gravity. So I'm still talking about the same thing. But
we are talking about gravity still, are we not?
Yes, we are.
Right, so down is
I am
defined
just
by the
talking
direction
about
in
the
which time...
basicness of down right now.
Yeah,
right?
but
And we all know what down is. All right.
Yeah, but no, we don't because you think it's to the you think
I'm
it's
not
something
going
to do
to
with...
ask him about triangles. We've been there. That's been done. Okay, I'm not going to ask him about triangles. All right.
Don't ask me about triangles. I want you to identify what you understand
my
the word
chat
down.
We're telling me to ask you about triangles. So I was just saying that I'm not going to do that because that's been done
Fine.
to death.
So what is down in the context of gravity? Is it down towards your feet, like you said, subjectively, or is it actually, according to the science, down as defined by the direction in which time passes more slowly?
The same thing.
No, they're not.
They're
not. One's Newtonian, one's Einsteinian,
And
one's
the same
mathematical.
thing when you talk about physics and how we can calculate and measure things, down is down.
Listen, here's another thing. Time's a concept. It's a man-made construct, right? It's not real world. So we go back to the...
No, time isn't a man-made concept. The measurement of time units is a man-made way of describing time. But time
and the problem
is not
with
a concept.
relying on
Time is a dimension.
Right, so, it's still a conceptual thing that man's made, right? And we're still going to try and rely on...
Time isn't a conceptual thing that man has made. What we've done is we have figured out how to measure and break down time into units. So that we can tell the time
is a construct,
and things like that. But time itself is a physical dimension.
Yeah, but not physical.
Oh, sorry, not physical. The word physical there did not mean to come out. I apologise. Time itself is a dimension. As you read within that definition of space-time, it's the third dimension that brings together space-time.
So space-time. Let's go back to the definition of space-time. Space-time is any mathematical model, right? I don't need to go any further. So time is mathematical by nature, but you're going to use it in this context of gravity, and I'm going to say, but you're still reverting back to Newtonian principles where you're going to use try and define down as towards the center of your feet or from your head or whatever.
That's because Newtonian physics is perfectly simple, it's perfectly acceptable to describe things that we see and measure, because we can still use the equation F equals gm1 m2 over r squared to calculate everything in the universe and the reason why it's moving. We can still measure a downward acceleration. Again, Anthony, you are arguing semantics when we both know what down means. All right? We both know what down means.
No, you don't know what down means. That's my point.
We do.
Down means is the direction in which time travels more slowly according to the current science as defined by Einstein. Yeah, and you're going to redefine it as up to your feet.
That is because of time dilation, and that is a fact. That actually happens. Time goes slower the closer you are to gravity. But down can also be described as a direction when we are talking about it. And we know that things fall down towards the Earth.
No, not towards the Earth, in the direction in which time travels more slowly, according to the current science.
Okay. And we're going to say that is Earth. Okay? We know that down...
No, we're not going to say that's Earth. That's going against what Einstein says. Einstein clearly states that it's the direction in which...
Again, you are trying to completely separate Newtonian physics and Einsteinian physics when that's not how it works. Einstein he expanded on the knowledge of Newton. He figured out that
didn't.
Newton was wrong about a lot
No,
of
he
things
didn't.
because it
Einstein
isn't just an invisible force.
No, Craig.
But we
Einstein
can measure it
snapped.
as a
Craig.
force because there is an acceleration.
No, Craig. No.
Yes,
Einstein
Anthony,
snapped.
I'm sorry, but you are completely missing
Right,
the
I've
entire
muted
point.
him for the purposes of my audience. He's clearly wrong. It literally says on screen that he snapped the wand in two by showing the curvature of space-time and not an invisible force. He did not add to it. He did not.
I've already explained to you
he
that
snapped
yes,
it in two and showed that it
the
was,
curvature of space-time is what causes the non-locality of things to change.
This guy refuses to accept it, and it is the pivotal point for why he's pushing bullshit science that's antiquated, and according to the current science, it's Einstein, right? Not my problem he doesn't accept it, but you've literally got the current science on screen right now. Where do we go from here?
Did you read the entire article, Anthony? Because you
I
clearly
read it
didn't
100
beforehand
times.
when you said you skipped through it.
Yeah, that was for the purposes of your video. I've read this 100 times. What else is there in this article that you don't think I've got right?
Again, that article is someone's opinion about things.
Right, so that you're saying that a PhD level scientist is wrong and some bloke
I'm not
on the
saying that he's wrong, but I'm saying that you should not use a Scientific American paper or article to try and prove anything.
I'm not trying to prove
Einstein
something.
attributed the curvature of...
No, Craig,
Sorry,
I'm not
Einstein
trying to prove...
attributed the reason why things fall to the curvature of space-time.
Craig,
I'm not going to deny that.
Yes.
You can say he snapped the wand in two because he figured out that Newton was wrong, because it's not just an invisible force.
Craig, listen, let's be clear. I'm not trying to prove anything other than show that you are antiquated with your so-called science and you don't accept the current Einsteinian science. I don't give a shit.
Anthony,
I don't give a shit which way round it is.
You keep trying to separate the two, and that's not what happens. Right? You keep missing the entire point of everything.
Really?
Answer me this then. What would cause the curvature of space-time?
It's mathematical concept. It doesn't have a cause. It's not empirical by nature.
The curvature of space-time doesn't have a cause. That's another... The amount of clips I'm getting from this is brilliant. Right,
yeah, that's right. So take this. I'll tell you what I'm going to do. For that little jib there, I'm going to just literally speak over you. Theoretical physics is pointless without experimental tests. A mathematical construct, Craig, cannot give you experimental tests because it doesn't have any application in experiments. It's maths. It's mathematical construct. And look who just happens to be on the leading, like the poster child for this. Bloody Einstein. So if you're going to tell me that I missed the point, respectfully, Craig, I'm going to ask you to demonstrate exactly where I've missed my point.
Because we can still measure it as a force. Einstein even said that it is measurable as a force.
Einstein did not say that.
Wait.
That's
he said that it wasn't.
Citation.
He said that it wasn't it wasn't just an invisible. It wasn't an invisible force. It is the curvature of space-time.
Yeah, he specifically said it was not an invisible force.
Yes.
So why would Einstein?
Agree with
why
you.
Are you
it's not an invisible force, but it manifests
so you're citing
within
that he says
Newtonian
you can
physics,
still measure it as a
within
force.
the universe that we can see and understand as an acceleration. An acceleration requires a force. That is a physical fact that you
only according
deny.
to Newton. Only according to Newton.
No, I'm pretty sure Einstein knew that acceleration required a force.
Well, he snaps that, right, that can't be true because his mathematical construct for gravity doesn't require a force. Do you understand that? It's mathematical, philosophical at best.
Not philosophical at all. It's an explanation of why there is an apparent force.
All right, well, it definitely is theoretical physics, though, isn't it? It doesn't have experimental application.
You mean Einstein's explanation of space-time?
Correct. It doesn't have experimental application.
Well, I would disagree with that because we are able to actually see the difference in...
so go on then. How are you going to demonstrate bending of space-time?
I'm trying to formulate my thought here.
All right, well, while you're formulating, answer me this in your thought process. How are we going to demonstrate the bending of space-time? What is space-time?
Space-time is the fabric of the universe.
No, it's a mathematical model, Craig. So how does a mathematical model have
model of the fabric of the universe that we can use to make predictions?
Right, a mathematical model doesn't have any application in experimental tests.
Right. What about field equations? They're
string theory. You mentioned string theory before.
Yeah, I mean, I don't actually ascribe to string theory. I more follow quantum loop gravity as an explanation of like the vibrations of energy of the universe.
Yeah, but again, it still lacks experimental application. Mathematical
I think the
constructs are
people at
not.
CERN would disagree with you there.
Why? Why would you think that? You cited Einstein before as saying that force would be required, right? And now you're citing CERN as people at CERN would disagree with me. What's your citation for that then?
Well, the fact that CERN is actually breaking down particles to try and figure out, what the fabric of the universe is.
All right, that's a lovely story. What evidence have you got that CERN would disagree with Anthony Riley on Sleeping Warrior on YouTube? Obviously, you've got none.
Right. CERN.
So,
you know what CERN does, right? They smash particles together to...
allegedly.
Allegedly, right. Okay, that humongous thing is just there doing nothing.
Yes, right. So what is CERN going to prove to us, right? Come on,
CERN,
what's CERN
CERN
going to
can
prove?
how... well, in fact, it has proven that a Higgs field is a thing.
Lovely story. What's that? Right, I'll give you CERN. You can have CERN. I'm not interested in CERN. LIGO, gravitational waves, detection of gravitational waves.
Yeah.
Is that science or is that pseudoscience?
That's science. It's
How is it
measurement.
science? Measurement. Right. So you ascribe then, therefore, that Bob from Globebusters proved the rotation of the Earth with his measurement, right?
Yeah. That
therefore-
gyroscope very much proved the rotation of the Earth at 15 degrees per hour.
Right. So therefore, you would then agree with me that if you're going to say that Bob proves something, that if you're going to say that he measured something, he's got to also manipulate your independent variable to prove that it is the cause of the effect that you believe you're witnessing. Do you agree with that?
Well, I didn't say he did an experiment. I said he did a measurement.
No, but we did say prove. I did use the word prove intentionally.
Well, you do know that I've kind of said the words wrong sometimes. I always say the word proof, but that's not really what science does. Science tries to explain things. Like science isn't really there to prove anything.
No, that's not true. That's not true. Right, on screen right now, I've got an article I'll send you a copy of it in the chat. Bear with me. This is what science actually does. There's your copy, and it is at the bottom of page 3.
The average layperson may think the above picture and think this may be true in some disciplines.
No, hang on. It's go to the bottom paragraph, just above the word experiment.
Once the hypothesis has been established, it's time to test it. The process of experiment is designed to prove or disprove the hypothesis.
No, you're on the wrong paragraph.
You mean the bit where it says about disproving or disproving the hypothesis?
No, it says one thing is clear about the requirement of the testability of the hypothesis. It must exclude supernatural explanations. And I'll say that that's gravity, but anyway, it carries on. If the supernatural is defined as events or phenomena that cannot be perceived by natural or empirical senses, then they do not follow any natural rules or regularities, and so therefore cannot be scientifically tested. Now, with regards to testing something that you measure, if you're going to claim that Bob proves the rotation of the Earth by measuring 15 degrees an hour with a fiber optic gyro, you have to manipulate that thing that you believe is the cause. It is required, and I can put them on screen right now. There's literally.
Let me rephrase right. It's an evidence for the rotation of the Earth.
Sure, but words have precise meanings in science, right?
Yeah.
They're not wishy-washy.
I'm retracting the when I said it proves, because I don't like to use the word proves anyway. What Bob gave us a very good evidence of the rotation of the Earth.
Craig, if you're retracting it, does that mean therefore that Bob did not prove something about the rotation of the Earth?
Like I'm saying, Bob gave us very good evidence, right? And
I agree.
It can go towards the body of evidence that we have of other things.
So did he or did he not prove the rotation of the Earth?
No, he gave us evidence for the rotation of the Earth. That's
so the answer is no. The answer is no, and I agree. He didn't. He measured something, but he can't. He doesn't know what was measured. And let's just be really clear as well.
Was a 15-degree shift, right?
And yeah, but let's just be clear.
That is what you would expect, right?
Let's just be clear, Craig. It wasn't actually Bob that did something. Somebody else did do something, but it wasn't actually Bob.
Yeah,
but
I know the whole thing of whether it was but it was the people that had that paid for the gyro and stuff. They did the actual experiment, and Bob was the one that was looking after the information.
Sure. So Bob didn't actually prove anything, did he? Somebody else may have proved something, and the thing that they may have proved definitely wasn't the Earth rotation, because it was subject to the measurement of 15 degrees. That could be the sky too. Agreed?
No, that's not how a gyroscope works.
Oh, really?
Yeah.
So you're going to tell me how a fiber optic gyroscope works, are you?
Yeah.
Go on then.
fiber optic gyroscope works by measuring the difference in the light that's traveling around it and where it is based on the movement of what it's on.
Not the movement of not based on the movement of what it's on. It measures the light around it, full stop. That's where it stops. It's not relative to the movement it's on. It's the light around it. But if we see the stars are already moving around us and we think the stars are moving and it measures 15 degrees of the light moving around it, that actually supports the idea that we're stationary and it's the stars moving above us. Yet you ballers misrepresent what's actually going on, and you don't address the second part, which he says, which is if it was really the Earth rotating, the physical mechanical gyros would also show that 15 degrees because they do measure momentum, whereas the
I can
gyroscope
give
measure
you
light.
a video that shows a mechanical gyro compass doing exactly that.
Is it inside some other receptacle that's software controlled?
No, it is sitting on a bed of water.
Has it been repeated by anybody? Is it scientifically validated as conforming with the scientific method? If not, we're not going to be accepting it.
Oh, well, many things you presented me of them, but what I can present you with is evidence.
All right, I'll give you the evidence that you present. I'm not sure what you're going to present, but I don't really want to dwell on it. My point at this point is that the fiber optic gyro measures 15 degrees of something moving, but doesn't prove what is moving. If we can agree with that, we can move on and you can have your point.
All right, let's say the fiber optic gyro, or the laser gyro, whatever it was, doesn't necessarily show the rotation of the Earth. But when we compare it to, where's the Skype gone? Things like a video. Sorry. Where's the bloody chat for Skype? You know what? I'll post it in your chat, in your thing. Right.
Sure.
I've just put a video in there. If you could allow that.
Where have you put it?
In your chat on your stream.
In my chat on my stream. Do you mean? Oh, right. Okay. Hang on.
Sorry, I've got too many screens up and I couldn't find the text chat for the Skype.
What do you want me to do with this? Play it?
You can look at that another time, but that is showing a mechanical gyro compass measuring the 15-degree rotation and finding true north.
So a guy called
that is showing the same effect as the gyroscope that Bob or whoever was using, but in a mechanical sense. So it's showing
you're actually going to cite a guy called Scott McPeak Gaming, who seems to be a gamer with 46 subs, as a credible explanation for a gyro compass. Really, is that really the credibility of what
it's the only actual one that I could find on YouTube, but it's something that I'm trying to replicate myself to do as well. And I think other people should try and do this, but it is evidence of a 15-degree rotation per hour, the same as Bob gave us evidence of. There's nothing that makes Bob's measurement any more valid than this guy's measurement, because we can say that neither of them are scientific experiments, right?
No, I'll give you that it's evidence, right? But when it comes to the credibility and the strength of the evidence, some bloke with 46 subs called Scott McPeak Gaming is not that
it's
credible.
Not the most credible source in the world, but it is an evidence, and it is a starting point that people could repeat themselves.
All right, I agree. It is evidence. And what I'll do is I'll respectfully charge Bob with a Summit for Globebusters content. So I'm pretty sure he'll be happy to address this on a Globebusters. Do you ever watch Globebusters, Craig?
I have done. I got banned the first time I ever spoke on there, but yeah.
Well, I'm pretty sure that given that this nature is the nature of this topic is quite contentious and current, I'm pretty sure Bob will be happy to have a look at this.
I would like to hear Bob's explanation of this. And again, this is just one random guy on YouTube with a few subs, but it's something that other people could do, right?
46 subs.
We all start somewhere, right? Come on.
All right. So I'm sure Bob will oblige. I think he's in chat, actually. He was in chat earlier on. I don't know if he still is, but I'm pretty sure if anybody's out there that's paying attention, just let Bob know that he's got a challenge on the table from a bloke with 46 subs, and I'm hoping that he'll address it. I'm pretty sure he'll be able to rattle this off for you, no problem. But anyway.
But again, that's just one evidence. I mean, that when I first looked, on YouTube a few months ago for this, that's just the first thing that came up, and anyone can find that and see it, and more importantly, it's something that anybody can repeat for themselves. And
I'm sure they'll do it.
That there's nothing there that's any less valid than what Bob did.
All right.
Would you agree with that?
I don't know. I haven't looked at the video. I don't know what you're asking me to agree or disagree to. All I'm saying is that it'll be put under his nose, and if he chooses to address it, he probably will do because he likes doing stuff like this. He might not do. He might.
I'd like to hear. Again, I agree with you that it's not the most credible source in the world, but it is an evidence that this happens, and it's in a way that anybody can repeat and do themselves.
I've given him a thumbs up to show support. Right, so where are we? All right, so we're back to, ultimately, we're still back to the idea of gravity existing, right? And if you're going to claim that I need to have an alternative or whatever, I'm going to say, well, there is an alternative, but you refuse to accept it because you say that it lacks vector.
Yes.
But the vector comes from the density of the relative densities of the objects that are in question. That's where the vector comes from.
My problem with that is that what is causing those relative densities? Why are they deciding to sit in that in that structure? Why, when you drop the cherry tomato in that, would it drop down to level 5?
Because do you agree that it can't maintain two places at once? It can only take one place.
I would say that it would have to have a reason to decide not to be in one place.
Yeah, it's called disequilibrium. So if its value is not equal to the medium it's in, it's going to displace relative to the medium it's currently sat in. And if that means it displaces up or down, in this context, I'll use it loosely, but up or down because of its disequilibrium, that then allows it to find its position, its relative position relative to the medium it's in. So what you're claiming is, well, you need to provide a model. Well, I can provide a model, and I know that you disagree with me and refuse it because it lacks a vector. But by virtue of the density disparity between the two mediums, the two objects in question, that is the vector. That's where it comes from. So, I mean, yeah, you can disagree with me on that, but at least acknowledge that there is an explanation for it.
No, I can't, because the explanation is flawed, and it's so flawed at such a basic level. I've had the same argument with Flat Earth Jesus, and you're not quite as wrong as Flat Earth Jesus with things, because I'm pretty sure you don't think the moon was dug out of the Grand Canyon by giants, do you?
I don't know where the moon come from. It could have done.
Do you know Flat Earth? Do you know of Flat Earth Jesus?
No, I don't. But
oh my goodness, right? And I've had the density argument with him as well, and the way that he tried to describe it to me was the reason there's a vector is because of everything, the air pressure above it is all pushing down, creating the density. It's just relative. As far as I can see, it's relative to the medium it's in. But the thing is, though, if you're going to disagree with me, right, and you're not even going to credit me with an alternative explanation, right, how can I accept your rejection of the Einsteinian point, which is it snaps the wand in two, blah, 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 and it's literally the current science? If you're going to dismiss mine... Because I've explained to you why it's wrong, and I can explain to you why your explanation of a vector is wrong. But
you're not... Yeah, but all right, I'll agree that you disagree with me on the vector point, but I don't agree with you that you can dismiss the citation that I've got on screen now from Scientific American, demonstrating the current science as accepted by the scientific community, right? You disagree with that, and I say that you're pissing in the face of all the science. So you're denying science.
What about you're obviously going to disagree with the fact we went to the moon, but the Newtonian physics is what we use to send rockets up. Our understanding of F equals gm1m2 over r squared, it is what we use to be able to calculate why things move.
I'll give you the moon landings are real. I'm not interested in talking about the moon landings. What I do want to talk about is what you mentioned on non-sec recently. I've got a clip from non-sec where you were talking about you measuring the distance to the moon, right?
I've got the details of that here. I knew you were going to
ask great. Right, so what you actually said, I'm going to play it for the benefit of the audience. You should hear this because it seems to be passing through, which is great. I'll stop it. I'll provide commentary at the end of it, and then I'll invite you to explain what you're referring to, because I'm going to call bullshit on it for a couple of reasons, which, based on your explanation, we'll have a conversation about why this is bullshit. But let's hear what you say.
Distance to the sun. I didn't. Wait, let me explain. When I figured out the distance to the sun, I didn't use any figures that anyone had told me. I looked at Venus through a telescope. I figured out the parallax of Venus. Using that, you can figure out how far away Venus is. And then using simple trigonometry, you can figure out how far away the sun is. I didn't get anyone else's information on that. I did that with simply with a lens inside a telescope, right? So, and We know these things work because
All right. So first off, when did you do this?
A long time ago, like before I ever had a YouTube channel or anything.
Was this academically, or was it done for your own leisure, or what? What was the circumstances?
Kind of curiosity, to be honest, because I'd seen it being described, and I wanted to see if it could be done. Where I said I didn't use anyone else's data, that's not particularly true, because when you work out the parallax, you have to take it from two different places.
Okay,
So-
hang on, stop. Let's not jump past this point. I want to know when you did it. Whereabouts were you in life? Had you just bought your first house? When did this happen?
It was a long, like, probably before I joined the Navy, to be honest.
Roughly what kind of year would that be?
2000-ish? I can't remember.
So what you're saying is that you had a telescope and you observed the parallax of the transit of Venus and calculated the parallax based on the transit of Venus, right?
Well, again, like I was trying to say, it's not just with... You need two observations to do it. So, I did as best I could, measuring the angles of Venus transiting, and then compared that with some details of someone else that was doing it a long way away. And then you can literally create like a triangle from your 2 points to where Venus is. And
right, I'm specifically asking you when. So you said it was probably before you joined the Navy. When did you join the Navy?
2003, 2004.
So before
Maybe
that,
2000,
right?
I'm going to say 2004 when I did it.
All right. Do you know when the last transit of Venus was?
There was one a few years ago, but I know there was one around 2003, 2004.
Really? Have you got any citation for that?
Yeah.
Because if you're going to measure the transit of Venus and create your parallax from that and use your ratios to get it, you at least need to know when the last transit of Venus was, right?
Yeah. Bear with me. So the second most recent transit of Venus observed from Earth took place June the 8th, 2004.
Yeah, that's what I've got on screen right now. But you didn't say it was 2004, did you? You were implying that it was around about 2000.
Like I said, a long time ago, Anthony. I'm 35 now.
Right. So when in 2004, how old would you have been?
What am I now? I'm 35. So yeah, like I said, this was many years ago, and something I did.
Answer my question. I have got a direction. How old were you in 2004?
I was 22.
22, right? Do you know do you know where the distance to the sun actually comes from?
The 1 AU.
Yeah, that's Kepler's law, third law on interplanetary motion. But do you know where the distance comes from? Not the ratio, the distance.
The 93 million miles.
Yeah.
Well, you can figure that with basic trigonometry.
Right. But given that you claim that you did it in 2004, which you were a bit wishy-washy on, and I call bullshit, but let's just give it you. Let's just say that you did it in 2004 when you were the age of 22.
When's the next one? Because I want to do it again. Bear me 1 sec.
Hang on. Well,
no, carry on. I'm just going to look for when the next one is, so I can actually do it. But carry on talking, just while I'm looking this up.
All right, so I've done quite a lot of research into the distance to the sun, and I'm going to cite to you a document from NASA. And it's originally cited by a guy called Christian Huygens in 1659. He's got a method that was described by NASA as both ingenious and accurate, which deserves to be better known. And I would credit you with doing exactly what this document says, because if Christian Huygens' method that was ingenious and accurate and deserves to be better known, and we've now got Craig McNeil from Flat Earth or from the YouTube discussion repeating his observation, I tip my cap to you, sir. I mean, that's fantastic. However, he was living in Paris and he determined the shape of Saturn. I'll give you this link in the side chat in a sec. He says Huygens wanted to give the sizes of the objects. In this case, he's talking about the Earth, the Sun, and Venus. He wanted to give the sizes of these objects relative to the size of the Earth. So that's the Kepler's law, third law on interplanetary motion. He knows the relative sizes. He knows the relative distances. I agree. He knows relative because he's got Kepler. He knows the relative distances of the planets, but in order to convert his angular measurements into Earth diameters, he needed to find the distance from the Earth to the Sun in Earth diameters. And this is where it gets a little bit sticky. Huygens solved the problem with an assumption. He assumed, or he supposed, that the planet Venus, aside from the fact that we can't even prove that it's physically a planet, it just appears to be a light in the sky, but he assumes that the planet Venus was the same size as Earth. Well, that means that you're calculating your angular size based on the Earth being a fixed size, which you believe is based on Aristophanes' calculations with sticks in the grounds, which let's just give him the benefit of the doubt and say that he's correct, even though Neil deGrasse says that it works out both ways. If you're going to base your assumption that Venus is the same size as Earth, which itself was based on the assumption that it was spherical at the time, which, bearing in mind, Aristophanes was 250 years before Christ, and I'd love to know how he knew that it was spherical before Christ, given that the most he could do was wander about the Mediterranean Sea on a camel. I'd love to know how they knew it was spherical. But anyway, if he's going to assume Venus to be the same size as Earth, that then gives him a size for him to then use basic trigonometry. Now, if you don't assume that it's the same size as Earth, you haven't got the ability to use basic trigonometry as you claim, because you need to know its actual size, Craig. You can't
I will grant you that I have to assume that Venus is roughly the same size as Earth to do this, all right? I will give that to you.
So right? that's kind of fallacious, though, isn't it? Because what if it's not?
Well, it's been shown to be that. Now, thing is, when you start with things, you kind of have to start with an assumption. And then
no, you don't. That's not what science says. You can make the prediction and then you have to test it. But if you're going to make the assumption to start with and then stand by it, then that's a bit of a problem because it's based on a presupposition, right?
Right. Yeah. But okay. Yes, I was going with the accepted knowledge of Venus being approximately the same size as Earth. But this has been shown to be the case since it was an assumption.
Really? So
yeah,
where's the proof?
We have satellites orbiting it. We've
No,
actually gone and physically measured it and stuff. I mean, obviously you're going to ignore the fact that space is real and satellites are out there. But
Craig, we don't have satellites orbiting anything.
That's a massive assumption.
No, we don't have. I'm not assuming. I'm definitely not assuming.
See, I say
this
we
is
do.
the best. This is the best evidence.
We can use the satellites for data. So you can deny space travel all you want, but
Craig, listen. I'm presenting to my audience now. Craig, I'm presenting to my audience now the best available evidence that we've got for satellites. The one fell in the Amazon rainforest, I think it was, or Bolivia or Chile or wherever it was. And it's best described as a balloon with a big massive canopy on it and what looks like scaffolding with a couple of car batteries, right? That's the best evidence that we've got for satellites orbiting anything. So I'm going to ask.
That's not the best evidence. The best evidence is that you can actually see a lot of them. That you can actually track them. In fact, I could go on my app right now and find exactly where they are above me. Understanding how GPS works.
Yeah, but hang on.
It's only possible with satellites. If we're going to argue satellites, Anthony, I can do that all day.
Sure, but if you're going to argue spectroscopy to prove satellites, I can argue that all day too and prove that it proves absolutely nothing.
I wouldn't argue spectroscopy. I'd argue physical observations.
Yeah,
I
that's
would argue
spectroscopy.
data that gives us stuff that we're able to do that wouldn't be possible if there weren't satellites in space.
Right, but the satellites that you're claiming are supposed to be constructs that are launched by a rocket that have ended up orbiting the planet, and I'm saying that you can't prove what they are. You believe that the lights in the sky that you're watching are satellites, but you can't prove it. You're using spectroscopy to prove a tangible object was launched at some point by a rocket. I say no.
I've seen rocket launches. Red's Rhetoric has been in actually physically recorded rocket launches. He watched the Discover satellite being put into space. And I've seen raw footage of that, unedited.
So when you say, did you just say the Discover satellite, the Epic?
Yeah.
So you're going to say now that Red's Rhetoric watched, oh no, not that one. It's that one. You're going to say that Red's Rhetoric watched the Epic Discover satellite that's supposed to have taken the imagery from Earth, from Lagrange 1 of the moon transiting the Earth. Is that what you're telling me?
Yeah, he recorded that being put into space.
Right, but there's no proof whatsoever that the crappy footage that he presented, or the Epic Discover footage that was presented by NASA, is anything other than CGI. If you think that that's credible evidence,
Red's Rhetoric doesn't do CGI. I've seen his raw footage, like from the memory card of his camera.
Right, but do you understand what the affirming the consequent formal logical fallacy is? If rocket launches into space and then we see satellite taking crappy CGI footage, therefore satellites must
Anthony,
exist.
do you know what the genetic fallacy is? Because you're committing that a lot here. I haven't seen it, so it can't be real.
No, it's not that I haven't seen it. It's the point that you guys can't prove that there's a tin can orbiting anything up there, but you claim that it's true. We can,
because the data is only possible if it's out there. For instance,
so you don't think data can be manipulated?
Himawari 8, and I can tell you about some observations that would only be possible if there was a satellite in space.
No, but you don't understand how software algorithms can work to demonstrate a point that you believe is real data, but simply the
I most certainly do. Like, there's certain things that cannot be done unless we're imaging things from space.
Like what?
Like in 2015, there was a wildfire on the Mongolia-China border, right?
Right.
The only way this would have been seen is with something high up enough up to see it.
And you don't think they could fake that?
The only thing that picked it up was the Himawari 8. And using the data from the Himawari 8, they were able to track and predict the path of the wildfire and save lives. That wouldn't have been possible without the data from Himawari 8.
So you're going to claim Himawari saved people's lives because it was a satellite orbit? So, right, all right. So then that begs the question, well, what is the Himawari? Is it a satellite orbiting in space?
Yes.
And how do you prove that?
Because of the data that it gives us every 10 minutes.
That's not no, that's not proof. If that's
it is, because it's not possible to do any other way.
No, it's not proof, mate. Right, first off,
okay, right. Let's not say proof. It's evidence that it is a satellite in space. Evidence that corroborates with all the other evidence of satellites in space.
Do you think?
If we want to talk about satellites, tell me how GPS works.
No, hang on. Do you think that the photographs, and I use that word very loosely, from Himawari are real photographs?
Yeah, they are. They're
real-time
images.
No, they're not. The composites, they've got to be stitched together.
No. Himawari doesn't do composites. Himawari images the entire Earth.
No, you're wrong, mate. You're wrong.
No, I'm not. Himawari doesn't do composites. Himawari images the entire side of the Earth that it's on.
Can somebody in chat give me a citation for the Himawari image citation? Because if you're going to claim that they're not composites, I'm going to call bullshit and I'll demonstrate it, although I don't have it immediately to hand. But I'm pretty sure somebody in my chat will come up with the citation that shows that they are composites. Right, let's move forward. I'll present it. Oh, hang on. Hang on. So somebody's giving me a link here. What I'll do is I'll present this on screen. Come on, Gleam. Oh, shit. Hang on. Stop. Chat's going too fast. Right, let's see if I can get it. Meteorological Satellite Center. I'm not sure. I'm just trusting what Gleam's giving me here, so let's have a look. Himawari 8 and 9 will have a dedicated meteorological mission. Hopefully this is going to be showing the bit that they are composites.
Right. Okay, now let's when it says composite in this way, what it's meaning is a composite of the spectrums of light, not composite that makes of different sections put together. The Himawari images in like infrared, in ultraviolet, and green, blue, red, and it puts those images together.
By definition makes it a composite image, right? Do you not agree with that?
Well, in the same way that your any imaging device can basically be called a composite because it takes the data and puts it together.
Right. So it is a composite then.
Not a composite in the same way as the 2012 blue marble.
Right, I've got it on screen right now. The words are: color images will be derived by compositing 3 visible bands: blue, green, red.
Yeah,
now,
but it's still one real-time image.
Yeah, but it's still a composite, though, isn't it? But the point is, let's just say that they're a real picture. They're not, but I'll just agree that for this point, that they're real pictures. Where's the picture taken from?
Where's the picture taken from?
Yeah.
The geostationary point above Japan.
So why do they have to put them together in bands?
Because that's the Himawari 8 sees more than we can. It doesn't just image in one thing. They want to have more information than just our eyes can see. So they image it in different spectrums, put that together so that we can see more information.
I'm just being told play the flipping video. No, play the flipping video. Gleam, is this right? So he's asking me to play the video.
Oh, Gleam, he's a troll.
I'm trying. Yeah, but he's got the citation that I asked for. So whether he's a troll or not, on this one point, he's presented the information that I want. Because I knew it was out there somewhere. I just didn't know it. I'm trying to press the video, Gleam, but for some reason it's not working.
But do you agree that the composite that they're talking about there is different to the composite of, say, the 2012 blue marble, which was literally different pictures stitched together?
I'm not that sure, to be honest with you.
Because when you look at the 2012 blue marble, it was, I think, taken over 16 hours, about 8,000 passes of the Earth, really close, and then it had to stitch those images together. Whereas the Himawari 8 takes one full image in 3 different spectrums and puts those together. What
I'm showing on screen now, I don't know if you can see it or not. Basically, it's the banded.
Let me go to your stream 2 secs.
I'm showing the banding that I'm referring to.
Yeah.
And after this point, I'm prepared to drop this point because I want to go back to the distance to the sun nonsense that you were talking about before. Because to be honest, I don't even accept Himawari as a valid argument, let alone a credible one. But this is the point. If this is supposed to be the imaging capture process that Himawari uses, I'm going to say that this is not actually going. It's not actually in the physical distance that they claim it's in, because it would be able to take one picture at this distance and it wouldn't have to band it.
Well, it's a lot of data there, Anthony. It
but this is not a render.
Together.
This is not a concept. This is not a consequence of rendering. This is the way they capture it.
It's because there's so much data.
One picture that we're giving you the benefit of the doubt, saying that it's a picture.
Yeah.
It's not.
Right. Now, let's talk about the distance to the sun and the Venus thing for a sec, right? The next one is November. The next transit of Venus that we'll be able to see from the UK is November the 11th this year.
Right. So tell me about this.
Wait.
How did you do this then? So you had a telescope, right? What kind of telescope? Was it one that was in an observatory, or was it just a thing that you had in your bedroom? What?
It was one of my friend's very powerful telescopes.
Right. So when you measured it, then you're obviously looking through a solar filter, because obviously it's going to burn your eyes when you're looking through it.
Yeah.
I'm assuming that. So you had a solar filter on it, right?
Yeah.
So when you observe the transit, let's just say that you had, say, 52 Venuses across. How many different photographs did you have over the period? Was it 52 or something?
Honestly, I can't remember. This is why I want to say to you right now that on November the 11th this year, you and I do the observations ourselves and put the data together and see what we can get. All right? I want to make a detailed video about doing this.
Yeah, I want you to do that too, because I call bullshit on this.
That's why I've looked up, and the next transit is November the 11th this year, right?
Well,
the reason why
I call bullshit on this is because, like I say, I've done quite a lot of research on this, and there's a citation on screen now from a guy called Michael von Beisen. I'm not quite sure exactly how you pronounce it, but he's crediting Aristarchus with some of the basic maths for calculating the distance to the sun. And he cites Aristarchus. He did get it wrong, but his maths what he concludes with this video is that his model of mathematics was correct, but the values that he put in it was wrong. So he superseded it with another video from a bloke called, bear with me, he credits a guy called Jeremiah Horrocks. Have you come across Jeremiah Horrocks, 1639? Jeremiah Horrocks is a guy born in Liverpool. He died at an early age of about 22, 23. His real name was John Horrocks, spelt with a K. I don't know why he's known as Jeremiah Horrocks, but he was a Scouse guy, bit like myself. Died at 22 though, and he literally is credited as getting an accurate distance to the sun, and he does it using the method that you've got. I'm going to respectfully challenge you right now in front of everybody to go through this video, apply the maths the way this guy does it, and tell me that this maths is valid, because there is a big flaw in this maths, and he misses something bad. And I'm going to ask you to demonstrate mathematically that when he goes through this video, that you come out with the same results as what he does.
Well, can I make a video about that and get back to you?
Yeah. All right. I want you to demonstrate this. I'll send it.
I'll tell you now that. Give me a couple of weeks because I'm really busy, but I will do a video on what you've asked there, okay?
Now I've sent you the link in the side chat, and I'll just put John Horrocks.
Send it to me on Discord as well, just make sure I get it, okay? But at the same time, I want you to agree with me that on November the 11th, you and I will both try and measure the transit of Venus and see what we come out with. And in fact, didn't you once say you were going to measure the transit of Venus using a solar filter?
Don't remember, but maybe. But here's the thing, though. If the mathematics is wrong in the first instance, what will be the benefit or the point to measuring it? Because we know that we can calculate the diameters of Venus, right? But if the maths is wrong, we're going to get fallacious results.
Okay, right. Now, I can agree with you that if the maths is wrong, then, yeah, you would get a skewed result. But I'm not exactly sure of what the maths is here. Again, I'd have to look through that, and I will do that and get back to you.
Well, hang on. Didn't you say that you used a transit of Venus and got the ratio, and that was how you calculated the distance to the sun?
Yeah, well, obviously you need 2 data points to be able to do it, which is why I'm saying you and I should do it from both our relative positions in the UK.
Right, so what I want you to do is go through this video and validate that this guy's maths is correct. And
Okay.
if you then do that, I'll then come back with you with one question, and I'll ask you to address one question that'll basically show that this math is wrong.
All right. Now, again, I will do that. Please make sure you send me the links, and that is something I will definitely do.
Okay.
Right? But whether it's, a fallacious or whatever, I'd like us to do this observation together on November the 11th, just to see what we get.
November the 11th, when this year?
Yeah.
Sure.
That's the next time from the UK we'll be able to get a good transit of Venus.
Sure.
All right. And that I want to make a detailed, video. I did all this when, I never even thought of having a YouTube channel, years and years ago. So I want to make a video showing how this is done. I want to do an in-depth explanation. Now that I never thought I'd be doing this, Anthony. I never thought I'd be doing this. But now I am.
Well, I'm going to say that I think you're lying about doing this in the past. I don't believe that you have done this because I don't believe you had the skills to do it.
If I can demonstrate that I can do it, then that will show that I wasn't lying.
Hang on, someone's saying that the transit is on Mercury, not Venus.
No, the next transit of Venus is November this year. I looked it up.
Let's just check.
Transit
I had it on.
Venus, 2019. Yeah, November.
Unless he was-
Oh no, wait. No, you're right. November 11th, transit Mercury as seen from Earth. When's the next one of Venus? Sorry, I read the wrong bit there. The next transit of Venus. May 9th. Transit of Mercury.
Yeah, but the next one I predicted for 2117. And 21 will be dead by then, mate.
I don't know. I'm going to upload my consciousness into a robot body. We can do the same calculations with a transit of Mercury.
Right. So he's right. He's saying the transit of Mercury is much more common, with the most recent one occurring on 9th of May 16, and the next one will be on November 11, 19.
Yeah.
So transit of it won't make any difference because we can still do the same maths to it. Just change the right.
But
Right.
I'll do what you've asked with the video of the maths. All right. But you and I will do this together. Okay.
But the problem we have, though, is the transits of Mercury need big telescopes because it's much smaller and it's a lot further away, isn't it? So its angular size is a lot smaller. We have a problem with practicality doing that on a Mercury transit. I don't think you can do it with a telescope. You need to have a massive telescope.
Let me think about it.
Possibly. Let's consider that as a possibility.
Yeah. But I want to do a video on how this is done and show exactly how it's done.
I want you to do a video on how you did it because I don't think you did do it, and I think you're claiming a credit. I mean, listen, when you said that the distance to the sun was 180 million miles, which you actually said 1,000, but
I was saying the speed of light for some reason and I said the wrong thing. I was in my head, I was trying to say the distance to the sun, but for some reason I was saying the speed of light. So I corrected myself by saying 1 AU.
Yeah, you do seem to stutter at times, and I wonder whether it correlates with telling the truth or not.
Usually it's because it's late at night when I'm doing those things, like 2, 3 in the morning, and I'm on a lot of coffee.
Telling the truth?
Sorry?
Is it correlated with perhaps telling the truth?
No, that's just how I talk, especially when tired and on coffee.
Right, so I did want to get onto the movement of the Earth in terms of sunrise and sunset, but we've been going for like 2 hours and 15 minutes, and we haven't really got anywhere. Let's try and wrap up summarily what we've managed to agree or disagree on.
Right. Well, I think we can both agree that the Cavendish experiment, measurement, whatever you want to call it, was able to measure G based on the torque and the torsion coefficient of the wire.
I can't agree to that unless you can agree that that's antiquated science and it shouldn't even be cited.
See, I really can't agree with that because the explanation that Einstein gives for gravity is, Newton was wrong about a lot of things. He didn't know about space-time or the mathematical concept or model, whatever you want to call it. But it doesn't change the fact that Newton's law of gravitational attraction is still an accurate thing that you can use.
But you've just credited and cited Einstein as still saying that Newtonian principles are correct, but I've got on screen that he says that it's not an invisible force, and that's the opposing position to what you claim from Einstein.
Again, I agree with you that it's not an invisible force, but it can be measured as a force because there is an acceleration.
Do we have a citation for this assertion then?
Yeah, physics.
Right, but this is where we got to before, and I said to you, like, go and look for your citation, because I'm saying that Einstein is not in agreement with you, but you're saying that he is, and I'm asking you for an evidence to support your assertion, and I've got it on screen, and I've had it on many times, saying that it's not an invisible force, and it's now the curvature of space-time, which you kind of agree
I'm
with.
agreeing with you that
but you're not
Newton
really
saw it as an invisible force because that was how it was able to be calculated, but Einstein attributed that force, or that apparent force that we see and can calculate, to the curvature of space-time, changing the locality of things.
He didn't stop saying that. He snapped the wand in two, mate. He didn't attribute it to a force. He showed that it was a mathematical construct.
Again, I'm not saying that he attributed it to a force. He explained why we can calculate it as a force and what it actually was. I mean, Einstein never disagreed with F equals gm1 m2 over r squared. Right? You know that, right? He never disagreed with that fact.
So, according to the Wikipedia definition for the Cavendish experiment, under the heading that states that whether Cavendish determined G, let's see how big this point is. It's not that big. I'll just read it. The formulation of Newtonian gravity in terms of a gravitational constant did not become standard until long after Cavendish's time.
Yeah.
Indeed, one of the first references to G is in 1873, 75 years after Cavendish's work. So if Cavendish did determine big G the way you're claiming...
Well, again, I'll explain, that wasn't the purpose of the experiment. The purpose of the experiment was to weigh the world, figure out the density of the world. Just a consequence of that.
But hang on, you did say
derivation of the maths, you can figure out what G is.
You just credited Einstein as agreeing with Cavendish over G, but we've just read from at least Wikipedia, at least, that the G didn't come until 175 years after Cavendish's work.
And that's what I'm saying. Cavendish wasn't trying to figure out G, but using the results from Cavendish and rearranging the maths, you can figure out what G is.
So...
And now we use modern versions of the Cavendish experiment to continually remeasure and remeasure G, and we always get the same measurement, be it maybe a bit more accurate.
So we're still back to the same point, though, that you kind of say on the one hand that you agree with me that it's not an invisible force, but then you demand that it's still applied daily. And although I agree with you, it is applied daily. That don't make it good science. It doesn't make it current science. And my position is that you should not be citing Cavendish as a proof of gravity when it isn't.
It's an evidence for an attractive force.
No, it's not, though, is it? There is no attractive force. It certainly is,
because it literally shows an attractive force.
Right, but there's no invisible force.
No, there's not an invisible force. It manifests. The warping of space-time manifests as a force.
No, it doesn't. It snaps the wand in two, mate. It doesn't manifest.
Yes, it does. Andrew, this is what when he says it snapped the wand in two, it's because it snapped Newton's understanding in two. Newton literally thought it was an invisible force, or he didn't have an explanation of why that force was there. Einstein came up with an explanation for why there is a force. He said, right, it's not even a force. He came up with an explanation as to why it appears that there is that attractive force. It's because it's changing the locality of things, literally by warping space-time. And then within Newtonian principles, within the calculations that we can make, it manifests as a force that we can measure.
Craig, you're claiming that manifesting itself as a force is equal to snapping the wand in two. Yes. I'm saying they're not the same.
No, that's the thing. Einstein never said that F equals G m1 m2 over r squared wasn't correct. And that is literally the force of gravity. Einstein never disputed that. Einstein never disputed that you can calculate an attractive force between things. What Einstein did was said that no, it's not a force, It's actually the warping of space-time.
Right, so
you
it doesn't
can
manifest
calculate
itself
it.
as a force then, does it?
Yes, it does. That's exactly
doesn't.
how it works within
No, it doesn't.
Newtonian physics. Is
Craig,
what
you're
we
denying
can
the
physically
science that's
see and
presented.
measure. All right, think of it like
Craig,
that.
you're denying
we
science.
can measure that there is an accelerating downward force.
Craig, you're
But
denying
Einstein
the
said
science
that's
that's under your
caused
nose.
because of the warping of space-time. This is one
Craig.
thing you need to get in. They are not mutually
No,
exclusive,
Craig. Right.
Anthony. And no matter how many times you
Muted
say
him now
that they
for the purpose of
are
my
not
I am
mutually
not
exclusive.
getting this wrong. Craig,
Einsteinian gravity is the
snap
Y,
the one, did you? It
Newtonian
doesn't
gravity
manifest
is the
itself
what.
as a force in Newtonian principles. It's gone, right?
No, it's
Snap
not
the
gone,
one
because
and
F
manifest
equals
itself as a
gm1m2 over
force.
r squared is still a
They're
thing.
opposite. They're the antithesis. They're not the same. They
Yeah,
are
they
not
are.
conjunct.
They
are
are.
disjunct.
Anthony.
So Craig's misrepresenting the science.
Just answer me one question.
And he's telling
Answer me
people
one
lies.
question.
This is called pseudoscience.
No,
And the
Anthony,
problem with
answer me a question.
pseudoscience, that's what's raping the real world of science.
Answer me a
Craig
question.
is guilty of pseudoscience.
Anthony,
and I think
can you answer me a question?
I really do. Craig, you're back in.
Can you hear me?
Yeah,
Sorry, can you answer me a question?
sure.
Did Einstein disagree that F equals gm1m2 over r squared?
I'm not making the point that he did.
He didn't, though, did he?
I don't care if he did or he didn't. I'm making the point that it doesn't manifest. Einsteinian gravity does not manifest itself as a force in Newtonian principles. That's bullshit.
No, it's not, because that's exactly what
It
it
is.
does.
One's mathematical, Craig. The other one is experimental.
Yet the mathematical model explains what is happening.
Yeah, but it
We
doesn't
can still
manifest itself as
use
a
Newtonian
force.
physics.
It doesn't manifest itself as a force.
Yes, it
calculates
does, because
No, it
Anthony,
doesn't,
stop
Craig.
denying that acceleration requires a force. That's a fact.
Craig, it doesn't manifest itself as a force. It calculates it using a bit of arithmetic. That's all it does.
It manifests as a force. We know that because we can measure that force.
No, Craig, there's no force, though. We've been through the definition of force. There's no interaction. And
There
even
is.
if there was,
And I explained to you why there's an equal and opposite reaction.
even if there
You're
was
just
a force,
completely ignoring and not listening to any
no,
of the
Craig,
things that
I
I
am
say.
saying to you that you are misrepresenting science as pseudoscience.
No, you are. You are completely misrepresenting science, entirely.
So basically, now we're at projection point. You're going to accuse
you've
me
been
of crimes
rejecting
that you're guilty
everything
of.
up to this point. The fact
I'm
is
what?
that we can still use the equation for gravitational attraction. Newton's
So
law
what?
of gravitational
So what?
attraction will never stop being a thing.
Craig, you can do maths to calculate anything. Don't make
Yeah,
it true, though,
yeah.
does it? Yeah, it doesn't make it true, though, does it? There's no causative effect with mathematics, Craig.
Anthony, you're literally just lying now and ignoring everything that's been said.
So give me one example where mathematics has ever proved cause and effect relationship.
Everything, ever. Maths explains the universe.
Right, proves cause and effect relationship, I said. I didn't say explain. I said prove cause and effect relationship. Give me one example where maths has ever done that.
F equals gm1m2 over r squared.
Right, that doesn't prove cause and effect.
It does.
It calculates
It proves there's
maths.
a force, and that the cause and effect is the mass of the objects, comparable to the distance between their centers. So there is a cause and effect with maths explaining what is going on.
Right, listen, Patricia's on, and to be honest with you, I'd rather go and listen to Patricia. We're obviously not going to agree. We're going to have to agree to disagree. However, I'm going to still state that A, you did not measure the distance to the sun, you're full of shit. B, you pass off bullshit pseudoscience as science, and you continually misrepresent Einstein's work as some kind of manifestation within physics of Newtonian principles, and you refuse to accept that it's gone. It's an antiquated science. It doesn't exist, and even if it did exist, it doesn't prove anything mathematically.
Right. Okay, you can say I'm lying about the Venus thing all you want. The fact is I'm going to do a video explaining exactly how I did it. And the other thing is, Anthony, you really do not understand the correlation between Einsteinian gravity and Newtonian gravity. You are literally trying to say that they are different things, but they're not. Newtonian physics is the what, Einsteinian physics is the why. No one in the scientific community disagrees with that fact.
Right. Well, actually, I've got it on screen now. Correlation is not causation. We've had this discussion before. Correlation is not the same as causation because we have a rooster that correlates with the sunrise every morning, but it doesn't cause it. Simplest example I can give. So listen, we're at the end of the day now. Patricia's on, and to be honest, I think we've flogged a dead horse now. Let's wrap this up, and I'll thank you sincerely for coming on and fighting with me for a bit, because it was fun.
And I want to again
enjoyed
apologise for yesterday. I wasn't trying to back out. It was a genuine problem.
No worries, and I appreciate your time for coming back today. It's been a long hangout, and I appreciate everything that you've done. I don't agree on anything that you've said. I have conceded lots, and we have actually been able to disagree properly without having to raise our voices too much, and I don't think either of us swore that much at all.
No,
so thank you.
I am trying to be calmer when I'm talking with flat earthers. I mean, when I first started this, I got very, very angry very, very quickly, but that's not conducive to a proper conversation.
For which credit is given.
This is one of the reasons why I won't go on Nathan's show. Because of, he will just mute me and talk over me and swear at me and stuff. I'll talk to Nathan on your channel, but I won't go on his channel.
Conspiracy Cats won't do it because he wants a proper channel. But I think that what we've demonstrated tonight, even though we've disagreed, we can disagree with people properly, and I think we've done that tonight. I don't think either of us swore that much. I don't remember swearing myself. I might have done once or twice, but I don't think you did. Maybe once or twice. And credit's given. I thought that was a constructive disagreement point, and we did well at it. So credit's given for that. I just want to shout out a big thank you to everybody that turned up and watched it. It was 235 at one point I saw.
What have I got on mine? Let's have a look. I just want to give you the opportunity to say what you'd like to my subscribers.
Fuck you lot.
I've got 459 watching on mine now. So that's like 800 total watching between you and my channel. So they've seen a decent conversation.
Yeah, I agree. It was a conversation, and I appreciate the fact that you didn't swear too much and you were amicable, even though we disagreed.
Yeah. I want to say to your subscribers, think for yourself. Never accept what you're told, but also don't dismiss everything if you just don't understand it. Thank you, Anthony. Hopefully we can have a conversation another time. I will definitely. Please send me the details of the things you'd like me to do, and I will do them for you. I will do a video explaining exactly where I did the transit of Venus. I'm pretty sure my mum's got all the books and everything. I wrote it in down in Bristol, so I'll see if I can get them.
Yeah, that'll be cool, man.
All right. Again, it was a long time ago, but I'm pretty sure my mum's got boxes of my shit. So. But we'll leave it there and
cool.
Go and enjoy Patricia, and I'm going to have a little chat with my subs. So
yeah, man.
Thank you very much.
All for turning up.
Have a nice evening.
You too, mate.
Bye.
See you soon. So now that he's gone from the call.
Right, guys. Thoughts? Any questions? If I've missed any super chats, I do apologise. Bear with me, and I'll have a look and read them out. Yeah, what did you guys think? Could I have done better? Anything that I missed or said wrong? I'm always open to criticism. Yeah, I'm pretty sure I need an aspirin. Super chats. Let me have a look. So we have quite a few. Thank you. Sorry, I didn't say I'm on the stream. We've got $5 from Gary Little. No message. Thank you. Paul Reap. $2. Apparently, math and science is the same. $2 from Tatted Philosophy. You can still owe him 3 dingus. Yep. $19.99 from Curve Pumpkin Hentowowski, the Laughing Jester. Oh, the pain for crying out loud, FTFE. Thank you. $5 from Orlor. Gravitational lensing is a practical application of space-time. Damn, I missed that. Thank you. $5 from Tim Pryor. First he says mathematics not reality, then he turns around and tries to use maths as fact according to what Einstein said. $2 from Area 85 Restorations. Valid experimentation requires mathematical model. 80 Knox. Not sure what that is. Thank you, Gunnar. Don't use your time on this idiot. He's so incredibly stupid. What the hell is he on about? Another $5 from Paul Reap with no message. 666 from 0132. Anthony is wrong. We sorted out distance to the sun in numerous ways over the past few thousand years. $5 €4 from Rory P. I offer you a beer for enduring this dishonesty. $5 from Craig Essex. Kill me now. I couldn't do that. $5 Canadian from Knockdown Will. Send Flerfs to space. Donate now. They don't deserve it, man. I want to go to space. $2 from Craig Essex for sending Flat Earthers to space. $2.29 from RapidX. There, bud. Thank you very much. And there's another $2 Canadian from Brainy Beaver. Touch my wet beaver. Again. Anyway, let's have a look what you're saying. I need to stop explaining things to him and show how his vacant his explanations are yet. Point out radio astronomy for confirming planets and physical objects. Yeah, I missed that. Sorry. Oh, did he just kept muting me? I wouldn't mute him because I don't think that's fair. But if he kept doing that, that just shows, really. Marvel Girl, you should have challenged him more when he called you a liar, especially at the end. He has no stand-in when it comes to honesty. I tend not to get into things like that. People can call me a liar if they want. I don't really give a flying fuck because I know the facts. So, after show. Yeah, actually, why not? Let's have an after show. Well done for keeping your cool. Better man than I am. Ready 26. Well done, Craig. Flint, I agree. You need to make him prove his stuff constantly and pick at that. Only his tactic is obfuscation and plain lies. After show on UDSA. Yeah. Well, I think I might do a live after show. See if we can get a few people on. But do we want to do an after show on UDSA, or should I do a hangout and get some people on? Let me know in the chat. 1 for on Discord, 2 for a live hangout. Yeah, I kind of wanted to let him direct the conversation because I wanted to point out his flaws. Maybe I should have prepared more of a script for him. After show here. Right, well, I'm not on Hangouts or anything. Hold on. Let me see if I can... Right. 2, live after show. Right, okay, what I'll do, guys, I will shut this down and then I will start up a hangout and get a few people in and we'll have a chat, okay? Thanks very much for watching, guys. I hope that's been enjoyable. I've got a bit of a headache, but I'll see you in a bit. Once I shut this down, bear with me. I'll play my outro while we intro.
We're living on a disk, floating through space, with a tiny sun